Welcome to the 24th session of the Scientific Review Board. Good to see everybody. We have our agenda for the next couple of days. Looks like we have 2 full days, Tuesday, Wednesday, and then some time scheduled on Thursday, Thursday morning. So off the bat, I want to make a suggestion. Olaf has a flight at 12:45. At 12:45. So, let's either that. Yeah. So what I think we could do, maybe shorten the lunches, working lunches, or maybe chop a half an hour off each lunch, something like that, to gain a couple of hours, and maybe extend tomorrow for us anyway, our drafting session.
Yeah, we do have some extra time in the agenda, which is just coming up on the screen now. And at the bottom of that is the schedule. We do have quite a bit of extra time that we sort of built in for additional discussion, and whether that's a matter for each of you to go to the individual groups off mic, individual teams within the Secretariat. Sorry, we're just getting a quick message. Can you hear us, Tara? Can I just get a thumbs up from anybody if you can hear at the moment?
They're indicating at the bottom they can hear you.
Yeah, I can see there's sound going through, but we cannot hear you, and I'm not sure. Can I just get a quick response that you can hear us?
A verbal response. Maybe we said we can hear you.
We can hear you.
Okay, perfect. So back to the agenda and schedule. So there is time built in. I'd suggest we just sort of play it by ear as we move through, and see where to from there, how we can juggle. Sounds good. Thanks. So the agenda is paper 01, which is just up on the screen. And yeah, back to you, Chair.
Well, that's my issue with the agenda, the schedule. If nobody else has a problem, any other adjustments that we need to make, and we move on. So yeah, we'll start off with Dave and IPHC process. Review of that.
Or thank you. I'm struggling with the IT ever so slightly. I'm trying to make sure that we can. There we go. Okay. Well, let's jump into the next agenda item. So we can look at paper 03, please. Okay, so paper 03 is the standard actions arising from the previous SRB meeting. Nothing new here in terms of structure and format for you. We do just strive as much as possible to, sorry, I'm fighting with the computer at the moment. We do strive to ensure that within the paper we have a basic purpose, what the background is, what the document covers. And then also ensure that as part of the discussion paper, we have very clear actions that need to be undertaken, a responsibility for that action, and a desired time frame. And so each of those are covered in Appendix A of paper 03. In addition, noting that this was the formal decision-making meeting of the SRB to the Commission, each of the action items have been addressed with an update associated with it, and in most cases, specifically referring to a paper that's before you at this meeting. Where that hasn't yet occurred, if it's an ongoing piece of work, will also indicate that it's going to be revisited in the future, such as recommendation 02 here. So unless anyone else in the room wants to correct me, I believe that each of these topics is going to be addressed throughout the course of the next 2.5 days in one of the papers and one of the sessions. And so there's no specific need at this point to go through each one in detail. We're on the assumption that you've already read it. But we can come back to these at any point in time and include them back into the meeting report if there's still further work to be done. And so with that, I'll pause and see if there's any questions. Not seeing any. Yep, go ahead. Sure.
Just on a different topic, going back to our agenda. The last flight is 1:45. So I think on Thursday, we could go till 11. I think would be safe. So we don't need to rush, squeeze too much. I think that's plenty of time to do the final review.
It should be. And even if we need to start a bit earlier, we can.
Yeah, okay.
Okay, perfect. Okay, well, noting that, and just a reminder that the purpose of this meeting is to provide direction or redirection to the Secretariat for the sessional work leading up to the September SRB meeting. And so while there's no specific need to come up with formal recommendations at this meeting, but rather sort of informal requests for action, we can tag anything that you feel you'd like to bring to the Commission's attention intersessionally and include those formal recommendations, noting that the full report gets sent to the Commission as soon as it's adopted or soon thereafter. Okay, let's jump into paper 04, please. Okay, so paper 04 is the outcomes of the 100th session of the IPHC annual meeting held at the end of January this year. Again, no surprises here in terms of overall structure. At the annual meeting, there were a number of agenda items discussed that had relevance to the mandate of the Scientific Review Board. We do just drop that those agenda items rather, into this paper just for reference so you can be reminded of what was presented to the Commission. All of those documents are, of course, available and the recording available for your review at any point in time. So again, this is really just a matter of providing a reference document for any particular decisions. The Commission did have a relatively light agenda or outcomes rather that were relevant to the Scientific Review Board. At the AM 100, those are provided at Appendix A, and probably most of them were functional in nature, procedural in nature, but it is worth flagging that the Commission did adopt a statement on climate change and requested that the Secretariat not only publish it on the website, but then also provide regular updates to the Commission on how we're operationalizing that statement on climate change through each of the subsidiary bodies. And in particular, there is obviously relevance there for the SRB about how we're implementing the research and monitoring activities through the 5-year program of integrated research and monitoring. So it's very much in its infancy in terms of how we're going to report out on that, but just throughout the course of this meeting, if you could keep that in mind, and we can certainly download that and send it to you. It's on the website. Maybe in one of the breaks, I'll put that up as well, and we can just have an informal discussion as well about how we can potentially report out on those actions related to the statement on climate change to the Commission later this year. Any questions on paper 04? Not seeing any. Then we jump to agenda item 3.4, Chair, which is updates from our observers, the two scientific advisors. I'm just quickly seeing who is online. Pete or Anne-Marie, are you online?
Yes. Hey, Dave. Good morning. Do you hear me?
Yeah, we do, Pete. Go ahead.
Okay. Would you like me to go ahead and ask my questions of the SRB now?
Go ahead.
Okay. So yeah, in talking with the U.S. commissioners, there was really just one question that came up that they would like to ask of the SRB, and it concerns the FIST design and it going forward. And there's a deep concern there that the IPHC will be forced to survey areas less frequently and with less stations, which of course would lead to bigger confidence intervals over time. And as a result, the commissioners may need to build more precaution into their annual TCEY decisions. And the question is, does the SRB have any advice for them as they consider how to guide the FIS design under a more austere budget?
We want to answer that now? Or we want to contemplate this? I mean, I have some suggestions.
We'll have some material on this as we go through the presentations as well.
That's why you have an MSE answer these kinds of questions directly. And not just piecemeal, to worry about the confidence interval of one FIS versus how that interacts with uncertainty in the population dynamics. Like all that stuff needs to be integrated into one thing. And that's exactly what the MSE is to do. So maybe I'll just flag when you're addressing that, just flag it so we can link those two back together.
Yeah, we'll present a few slides on that to you later in this meeting, and we've had some discussion with commissioners on the same topic.
Okay, Pete, so we'll address that throughout the course of the meeting, but take note of it. And if you could remind us as well, we'll come back and make sure that the SRB provides additional text in the report in response to that question.
Okay, great. Thank you.
And any others that the commissioners in particular are interested in from the US?
No, that was the only one.
Okay, brilliant. Anne Marie, are you there?
Oops, good morning. Here we go.
Good morning.
I have not managed to talk to my commissioners ahead of time, but so I'm reading between the lines with some of the different meetings that I've been in with them, as well as the rest of the Canadian caucus. And similar to what Pete had mentioned on the other side, is that I think there is concerns around the FIS design and how to balance data assessment with the financial constraints and how that's going to work in the longer term. So I think that's a concern on the Canadian side as well that I've heard around. Another one that sort of popped up, maybe it's a little more top of mind because we had the intercessional session on the MSE, but I'm sort of feeling with talking to various people that like the recognition that the Halibut MSE is not going to function like a classic MSE in terms of strict adherence to a defined management procedure. I think part of that is that I'm getting the feeling that that's not necessary, that isn't necessarily clear. And so I think part of that is affecting how people are viewing what the MSE process is and isn't. And so, yeah, I don't think there's a specific question here, but I think it's just something that I wanted to flag for the SRB when they get to the MSE part of the discussion is like the questions that the MSE can look at, but also how it functions and how it's used, and maybe a way to communicate the difference between the IPHC MSE and how it's implemented compared to, say, the way that the sablefish one is implemented.
And Marie, could you talk a little bit more about just sort of explaining what you mean by the Halibut MSE not working with strict adherence to a management procedure? Is the plan to have a much more flexible and ill-defined management procedure?
Yeah, my understanding is that we have a management procedure. It would be evaluated in the operating model, and we would have our outcomes, but the commissioners are still going to commission. So it's not, so they won't necessarily adopt or follow the exact outcomes from the management procedure or the harvest control rule or the different pieces of the management procedure, for example.
And is the feeling that they are unable or unwilling to quantify what they plan to do so that it could be evaluated within the MSE? Sorry if that puts you on the spot.
No. I don't think that it's that they're unable or unwilling to say what they're going to do. I think, oh, actually, not that they're unwilling. I think part of it is that it's difficult to say what the commissioners are going to do until we get to any given year and they're presented with the specific context of what any year sort of pops up with. And also, we have 6 commissioners and we have commissioner turnover. So the way that one commissioner will react or think about the information that's coming in is going to be different than the next commissioner who comes in. And so there is that as well. So I think that it is an extra layer.
Thanks. Yeah, I think it'll be useful to have some discussion about this because, one of the big benefits of the MSC is that it can tell you how a certain management procedure is going to perform. But if you're unwilling or unable to commit to that, even for a short time, then you don't get as much out of the MSC as you could if you were willing to
Right.
commit to trying a strategy. So maybe
So
we
is
can
it
have some discussion.
possible? Yeah, so I'm just wondering whether it's possible to explore like a management procedure space as opposed to a single management procedure. So we do this for Fraser Sockeye is that instead of telling people that we're going to adopt like this particular management procedure, it's more like viewing a giant map and it's like over there be dragons, stay away from that. But if you stay, generally in this area, the disastrous outcomes, the catastrophic outcomes aren't going to happen or are much less likely.
If they were willing to define that space, I'm sure the MSC could evaluate that space.
Mhm.
Yeah. So I have a couple of things. One of the reasons, the advantages of a formal management procedure is that when new commissioners come in and out, you don't get new behavior out of your management system. It's supposed to be based on the data and the objectives, not on people's individual tastes. That was one. The other is this actually confirmed that they don't intend to follow a management procedure? Like, I'm wondering, are you assuming this, or have they actually said, we're not going to do this?
I think that's my assumption based on how that might be something to check with everybody else in terms of, is this Pete, is this your understanding in terms of how the US commissioners are viewing the MSE and also staff, how we're viewing? Because I think at the annual meeting, didn't the commissioners put in a sentence around
Flexibility.
yeah, thank you.
Okay. I think we've been over this multiple times in this process, and I think we're getting to the limit of what we can say about this. We've said it many, many times, as Olaf just said. When you do simulations in a management, strategy evaluation context, the reason you're able to have any confidence in the results is that you're repeating the same procedure over and over. As you deviate from that procedure, your predictions are off, right? And it could be just, if your flexibility exercise of flexibility is random and it's small, then it's not a big deal. If it's systematically off, why even look at the simulation output? It could be totally unrelated. So that's one. The other is the map of the There Be Dragons thing. Like, this isn't that, we're not talking about obvious thresholds to avoid and things like that. Like, one of the reasons why you do the simulation is that you have these nonlinear interactions that are hard to observe, that you only get by simulating this thing, playing it out over time. So there could be things that are come out of that are qualitative things to avoid, but this isn't really a qualitative exercise. It's a quantitative exercise. So it's kind of a deep concept, but anyway, and the other, which I think we should, one of the things that anyway, I would like to recommend is that there be some formal adoption process by the commissioners where they decide to formally adopt a management procedure or not. Otherwise, we're going to keep building these questions, and this is not going to go anywhere. If they're going to do an MP, then they do it if, like, maybe formally adopting a management procedure that sets the TCEY, so that it's going to operate for 3 years untouched, and maybe they can negotiate how that TCEY is divided up among the regulatory areas. I think we talked about, this is one of the things that I talked about at the annual meeting, and I think we mentioned in our last report, is to separate, as you do, but literally separate the distribution of TCEY from the setting the level of the TCEY. So if they want flexibility, it depends on what they want it for. Yeah, I don't see how commissioners could have a better basis for adjusting the total TCEY than what you have coming out of your stock assessment and data collection. Like, I don't know how they could provide better information than that. Whereas in the distribution of that TCEY, I don't think the system is that sensitive to that. And maybe it is obvious that that has other objectives embedded within it that they may want flexibility. So I think that's something that I would like to recommend anyway to come out of this, is to formally address that issue of separating the TCEY and the distribution, and proposing to adopt a management procedure at some date in the near future that will apply for 3 years.
Sean, the way that you separated those things out, that might be a useful question in terms of the FIS question that came up, that Pete brought up, is where would that sort of fall in terms of, is it more towards coastwide TCEY or more towards distribution? So that might be helpful in terms of letting the commissioners know what might be useful questions for the MSC to look at if the intention is not to necessarily follow an MP, for example.
Yeah, that's a good point. That if the distribution depends on the FIS, maybe it depends on the uncertainty as well. Whereas the TCEY is kind of filtering out that uncertainty in the FIS. So that would be something for the MSC to formally look at.
If I could just add quickly, and so Alan's going to talk a little bit more later about the intersessional work that the Commission's been doing, specifically related to MSC and adoption of a management procedure, and the separation of the distribution elements from the TCEY determination through a management procedure. It is, even though this meeting is aimed primarily at the Secretariat in terms of developing requests for further development, I would agree, Chair, that it would be very useful for the SRB at this point to come up with some, again, sort of standing, more formalized, I'm going to say clearer simply because I don't think the message has quite got across to commissioners yet, not necessarily through any fault of the SRBs, that the Commission needs to make that active decision, whether they are going to adopt a management procedure or not. And some of the discussion at the recent intersessional meeting was that there was still a lot of hesitation to even go down that path. And I think the science advisors have a very large role to play with liaising with the SRB members and the Secretariat and trying to ensure that the 3 commissioners from your delegations are well versed enough to get to that point of at least deciding which way they're going to go. At the moment, it's very challenging for the Secretariat to come up with material each year for each commission meeting cycle that is then advised that it's insufficient at this point to make a decision, for the Commission to make a decision. So any clarity that you can bring to bear throughout the course of the meeting and in the report. I think it would be greatly appreciated that we can then, and science advisors can then very clearly take to the commission, ensure that they're fully versed.
I just jump in with one more thing. So I mean, it seems like there's this great new tool, the MSC, that requires some leap of faith to actually implement and use it. And I'm trying to understand where the hesitation comes from in implementing that. Saying the same thing about how this is good and they should use it, I think is not effective. And so I'm trying to understand what the concern is on the part of the commissioners with agreeing to a management procedure. And I think if I understood that better, we could give better advice that's more likely to result in that being picked up. Is it that they're worried that the management procedure is going to tie them into something that doesn't seem to be working and they won't be able to get out of it? Or is it that it's just a more vague concern about reducing their flexibility?
We will talk a little bit about this during the MSC presentation, and we look back at the last couple of years and the decisions they've been making and how they have departed from what our current interim reference MP is. And so that might provide a little bit of insight, but I think it's really about that flexibility and the desire by the commissioners to consider additional concepts that aren't maybe presented in the stock assessment or haven't been brought into the MSC objectives, such as socioeconomic concerns, concerns about, low FIS catch rates or low commercial catch rates and things like that. So we're going to talk a little bit about that during the MSC presentation. That's the specifics. The general question you seem to be asking is just, what is the desire there? Why is there this hesitation to adopt the MP and use the MSC results? And to be honest, I just think they desire that flexibility, the flexibility to make the decisions, to talk to the stakeholders, to see what their desires are, and then make the decision based on more than just what the stock assessment might present in that year of other indicators that they haven't, that they want to see.
As you know, one of the benefits of the MSU is being able to bring in those other
Yeah,
indicators
exactly.
and say, well, how do they actually perform?
Yeah.
And so it can be a data-informed decision rather than one informed by heuristics.
Yeah, and we're working on that. I guess another speed bump, you might say, it's not a barrier, but it's a speed bump, is the commissioners do not want to be overwhelmed with a number of objectives. And they really, even the recent discussion we've had with commissioners, it was very clear they don't want more than 4 coastline objectives in this process. We have, with the MSAB, we look at like 200 performance metrics related to lots of different objectives. But when we present to the commissioners, they want 4 objectives: conservation, target type thing, yield, and variability in yield. And even when we suggested maybe adding 1 more, they were no. So that is something that we have to be aware of, is just how do we really look at, use the MSE with the small set of priority objectives and present it to the commissioners in the way that they're actually thinking about making the decisions. And that's somewhat the discussion we'll have in the MSE presentation, is what is there an objective that they're making recent decisions on that we need to consider in this process? And so we'll have that discussion.
Great. Okay. Thanks.
One of the challenges that I see, because I go to the annual meeting every year and present this, and I get these, I get questions from the commissioners, but I'm thinking like maybe we should have a separate meeting so that we can have more of a conversation about these things and just tease it, like even your question. So now, what you just asked has to be filtered through some documents and then get back through some observers. So next year we might get an answer, but meanwhile things have changed. So I would suggest at some point in the fall, maybe we all go to one of the interim meetings and just have a separate conversation to address some of these issues, because IPHC is not the only ones going through this. There's others.
And management procedures can be designed that include important flexibility as well. And then, but it would have to be, described quantitatively. But if you can do that, then you can test them in the MSC, and then you reap the benefits of the MSC. So I'm sort of not wanting to give up on this amazing tool that the Secretary has developed. But seemingly the way we're giving advice doesn't. It's like there's this amazing autopilot for their votes.
Well,
everyone still wants to keep their hands on it.
yeah, I mean, it was interesting at the annual meeting. A bunch of people came and talked to me afterwards, and you can see the light is starting to come on. Like, people are starting to understand what the MSC is for, and at some point you just gotta try. Even if you tried for 3 years, like, hell, it's going to be here 3 years from now. You're not going to screw it up. The fishery's not going to collapse because you used an MP. And then you try it for 3 years, and then maybe see if you like it.
What I would suggest is the work meeting might be an ideal scenario for that. So that is currently the 5th, 6th of September. That's typically not an open meeting. It's just where we informally brief the commission on a whole range of topics, including where the MSC work is at in preparation for the public interim meeting. So maybe the 5th, 6th of September. I think it's probably going to be the afternoon of the 5th or the morning of the 6th when we specifically talk about the MSC work. Might not be an option. But even if we could get one of you to join us to present exactly this topic related to MSC.
I also, I was recently commissioned by the Marine Stewardship Council to write a paper addressing this very topic.
Saw that, yeah.
Oh, okay. So I'm wondering if maybe is that something we could recommend they read?
We're Dave and I have been talking a little bit about it, and that's a fantastic paper you've written, and it's inspired us along with a couple other RFMOs in their write-ups of MSE, and that Dave and I have been talking about maybe a short writing up something here at IPHC, a short digestible explanation of what MSE is in the halibut world. People are talking about, is this different than other ones? And maybe presenting it from the viewpoint that we've been working with and working with others like yourself, and getting some material out there that might be helpful for the commissioners and stakeholders as well to really understand this process a little bit better. But your paper for the MSC is something that we were definitely inspired by.
They basically said, can you write something, that's 5 or 6 pages? It turned out to be 14.
Yeah.
And then the northern shrimp, so we started working on the thing for northern shrimp, and like, can you boil that down to 2 pages? Like, come on, like, this is sign my name on the thing for less than 2 pages.
It's kind of what they need, though, in many respects. So the 14-pager would be for Pete and Anne Marie to help digest and explain the 2-pager where it needs to occur.
I have a couple of other we actually have come up with a 2-page one. I'll show you in between.
Great.
So if you're not necessarily available in person, maybe this thing we'll have a discussion off mic about where you're going to be in the world, and maybe we can call you in for half an hour. 5th and 6th.
The 5th, whatever time difference Taiwan is, but I could probably do that.
Just call in. I think it would be useful for them to hear directly from the news chair.
Okay.
Excellent.
Great. Okay. Thanks, Anne Marie. That discussion. Anything else? I guess that was your Anne Marie. Anything else you want to raise?
Nope, that's it. Thank you. And anytime.
Okay, so that ends agenda item 3, and so we can move briefly on to agenda item 4. And so this relates to paper 05, which is the current program of work for the Integrated Research and Monitoring Program. There are no specific updates that we're going to provide as part of paper 05, so that's just there as more reference material. However, we do have information paper 01, and that's related to the AI work that Basha and her team are working on and leading. And so if there's time now, we're ready to present on information paper 01. Could we have the PowerPoint presentation up, please?
Well, that was part of the monitoring session.
Let's go with it now.
Please consider it more of an informal discussion then. A warning would be helpful. Okay, thank you. So this paper is an update on the efforts that we've been doing here in the Secretariat internally on exploring the potential use of artificial intelligence for supplementing Pacific Halibut age determination from the collected otoliths that will be provided in the form of a picture into the model. So really the purpose of this paper and this presentation is to summarize the information available on the use of artificial intelligence for determining the age of fish from images of collected otoliths and provide an update on the exploratory work of implementing an AI-based age determination model for Pacific Halibut. And really the question to start here is why use AI-based model? AI-based algorithms can be trained on a large data set of otoliths images with known ages to learn the patterns and variations in growth rates. Once trained, this type of model can analyze the new otolith images and predict the age of the fish based on the identified patterns in that image. And why this could be of potential help for the IPHC is that this really could improve the consistency and replicability of the age estimates within the IPHC, as well as it could provide us time and cost savings as an organization. And as a result, we could have a wider set of the data that is available for supporting the management decisions at the IPHC. In terms of the approach that we were thinking for this particular project, we are thinking really about the approach that integrates the AI-based age determination and traditional aging methods for maximum accuracy of these estimates. So really here you would think about this approach as being more of a circular approach where we train the model based on the already labeled data. Labeled data means that we use the otolith images with the age associated with them that has been provided through manual aging. And then we can use the trained model and then select the next sample, trying to figure out which sample should be then used for further enrichment of the data set that we used for the AI-based model. Then we can use that new queried results that have been aged manually, and this could be some sort of subset of the main data set, and label or relabel the selected samples and use that additional data to enrich the model. So again, this is really an approach that integrates two sources of information, the AI-based model and additionally supplemented through manual aging. And why is that? We really want this model to also address the question of climate readiness. Training the model with inputs that capture temperature changes will ensure that we are prepared to also recognize the potential changes in the patterns as we move forward, and those images might be changing with the changing environmental conditions. So really think about this being a project where we are not only basing our model on the older otoliths and the images of these, but also making sure that we supplement the data moving forward with a good spatial good temporal variation, and making sure that we incorporate the images of otoliths from various time periods. In terms of the approach, we are using what is called convolutional neural network model, which is a type of deep learning approach. In this approach, the layers are structured as stack of filters, each recognizing increasingly abstract features of the data. So really, when you think about this approach, is the model kind of deconstructing the image into multiple layers that are designed to identify various elements of that image that might not necessarily be visible to a naked eye, but it's something that could be informing the model about the age that has been associated with that image as a label.
Maybe you're going to provide some, but like, are there some examples of what types of what these layers might be?
So when you think about the deep learning model, and this is probably the most common critics of this type of model, it's a little bit like a black box. You don't really see exactly what is driving the results. You really see you provide the input to the model and you see the output, right? So these layers are there's some research are trying to show what are the potential characteristics of the image that might be driving the results, but this is not something that is typically done. Typically, it's something more of you allow the model to get the input, get the output, and you more look on the output. And this is probably the major critic of a deep learning types of model, because you don't really see what in particular is driving the results. You more see the results and evaluate those results.
But the layers. So, for example, as you get your training set, and then you're updating that training set, the layers are they like constantly changing the layers, or are they fairly stable, or does it even matter? I'm thinking that maybe it's like principal components or something. Nobody knows what it is, but it's roughly these things.
It's not something you would typically look at. It's more of a, if you look at some of the research that's been looking at how to potentially deconstruct those images into those layers, they do show various kind of areas of interest in that layers, but it still will not tell you whether how each of this particular characteristic is driving the results. It's more of just a feature of a model. It's just deconstructing the image and looks at, and it's actually, in fact, it's not even looking at in the end that whole picture even within those layers. It's actually looking at the array of pixels within each of that layers. So it's really not something that you could analyze in a way that we think about searching for those rings on the image. It's a very different way that algorithm is analyzing that image. So it's really hard to say what is it driving results. It's really looking at it's really this type of models are focused on analyzing the results from that model.
And I guess if you have known aged fish, which you're continually testing an unknown age fish, then you're keeping it under control.
Yes, so that's the goal. That's why what I wanted to show is that circular framework where really I will show the preliminary results for the model now, but I think in the future what you would really want to do is it's also target what otoliths should be checked manually. So when you think about some of the subset being predicted with a good level of uncertainty versus really wide uncertainty interval, this being selected as an otolith that might require additional verification by the trained readers. So really thinking about this being more of this circular that each of the method is feeding each other so that you might arrive at the model that is well trained.
So the estimated ages come with an uncertainty as well? So you can use that to guide.
That's the next step that I'm planning to implement. It's not there yet. Again, this is really preliminary results. I've been working on it only since last few months, so it's still work in progress, and there are a couple of other things that I will be talking about in terms of where I think the model should be going forward, in terms of improvements for better age prediction in the future. But in terms of the approach, other things that would be important to keep in mind is that we do use for this model it's an application of an image regression. So we are predicting a continuous variable here. And this is for Pacific halibut, driven by the fact that Pacific halibut is a long-living species. All the Pacific halibut on record that we have in our database is 55 years, which is quite good number of age categories if we wanted to instead use the age as a category variable. This has been often applied for species that have been shorter lived species, where you have more reduced number of age categories for prediction. For Pacific halibut, just because there's it would be a lot of age categories, 55 as a categorical variable. We use instead the regression, so it gives a continuous number as an output. Then we use the rounded number as a prediction of age from that model. And in terms of more of a technical details, what we use here in terms of implementation, we use what is called TensorFlow and Keras libraries on Python, which repurpose Inception v3 model from Google. So we really don't use training from complete scratch. The typical approach is to use some sort of pre-trained model that is repurposed for specific applications. So in this case, we would use the Inception v3. So when we have an input, that input goes into that Inception v3 model, which is you should think about as an extractor of those features. So it's helping to deconstruct that picture in those layers that I've been mentioning. So it's a pre-trained model that is designed to extract those features from the image.
So when you say input, you're talking about
The image.
an image of a
Pre-trained. It's pre-trained to extract features of any image.
Original model, yes. And then what you have, so in the AI, you have those models are typically based on multiple layers. And usually those, you use the first kind of very basic what it means to extract a feature of an image. Those are things that have been used as a base. And then you only train the further layers where you specifically adapt your model to your purpose based on the images you feed it for the training purposes. So it's really a combination. It's not modeling from the very scratch. You don't train it with zero. You have some sort of basic starting point, where from there you take your images, you add them to the model to adapt that model for your specific purpose. And this feature extractor is put into that regressor, which is getting the results in terms of this continuous variable that represents age and gives us the output. And this initial framework is very closely based on a model developed through the project called Deep Autolet. This model has been somewhat similar model has been previously applied to other species in Greece and Norway. It's been by groups in Greece and Norway, and it's been previously applied to Greenland halibut, red mullet, and also applied to pictures of scales of sound. So really if you think about it, this type of model is, as I mentioned, it is coming with some sort of pre-trained feature extractor, but then it's then further trained on the very specific images that you use in your project.
And are you using the model that's already been trained on those species, or are you just using the workflow
I'm using their workflow. So I'm go back. I don't. I discard the piece that has been specifically trained for those other species. I go those layers back.
It's just a general image.
Yeah. So I just did a general image, and they use the categorical variables as well. So that's adjusted there, and then retrain that further layers to get that results for Pacific halibut.
Were any of those crack and burn? Greenland halibut and red mullet, those thin sections.
There are very different types of otoliths that have been used. So the Greenland halibut model is based on the full otolith,
On the whole,
whole otolith, yes. And again, that's the whole point of this model. So you use those base feature of the deep type of learning, and then you adapt it based on the specific pictures that you use for your project.
right. What images are you using? Is it a whole otolith, or are you getting that?
I'm going to show you some of the examples of the images that I'm using. So here are the examples of the images that have been taken. So these are images of otoliths that have been sectioned and baked to increase the for the human. We know that it's you can improve the contrast of the rings in the otolith through baking. So we use those otoliths as they've been already processed. And this is because we really want to benefit from that great resource that we have. We have in our archives, we have over 1.5 million otoliths that have been stored for potential future use. So we have this amazing, unique resource for AI training. So we want to use what's there already available instead of just kind of doing it on an ongoing basis. We want to go back, take the otoliths that have been previously already collected and aged, and use that as an input to the model. And yes, as I mentioned, those otoliths are sectioned and baked.
So that 1.5 million is physical otoliths, not images.
Yes, so we don't have 1.5 million otoliths images yet. We are at about 3,500 pictures now.
That those 1.5 have been aged already.
Exactly. So it takes time, it takes resources to take those images, but this gives us a great cross section of otoliths that come from very various regions and various time periods. So if you think about where one could develop this type of model that is really well adapted to various changing conditions, and
That's a good point. I mean, sometimes having that much data means you've got a large weight of irrelevant past information that's dragging the model down. Is there a way to sort of upweight the more recent otoliths so that it performs well on the otoliths you're trying to age now, distant past otoliths?
Sure. So that's definitely something that you would look through, looking at as you train the model and see how the results. What's the performance of the model? We are not there yet. We are currently focusing on taking picture of 2019 FIS, just because that was the last really large scale FIS where we have otoliths from all the regulatory areas. So we are focusing now on capturing a good spatial variation. So at this very moment, we don't have yet the cross section of like otoliths over time. We are focusing now on trying to make sure we capture the spatial differentiation of the otoliths. We know from our experienced readers that they've seen some variation between
Spatial variation.
Yeah. between so
Is there
the
any,
differences between regions.
is there any visually noticeable temporal variation? If you take an image from 1930 of an otolith in a particular region, does it look different from
Not that is very clear from the as a looking at the otolith from the naked eye. But maybe AI will know the difference. That's the whole point. Using this type of model, we can identify different things that are not very clear, or they are very difficult to kind of analyze. Just looking at those otoliths.
Can you pass the AI covariates, like the region it was collected from or the sex?
I will go for like in the next one of the next slides. I have the next steps.
Let her go. Let her talk.
But I'm glad to hear there's a lot of interest in the project. That's definitely something I'm looking at. That's definitely the next step. I have not the chance yet to include that, but what I want to do is really next step is, apart from just increasing the number of images that go into the training set, is really to look into the use of those auxiliary variables that could be helpful and could carry additional information that could help drive the results more towards better accuracy. And a few notes just from this slide is that taking pictures can be also incorporated into the aging process at relatively minor time added. It just it's not as streamlined as just taking the archival autolets and just having that as a separate process that we take pictures. And here you can see the camera that we are using. So this is the camera that is directly attached to the microscope. So we take those pictures at with predefined magnification so that they're more, it's more visible. At least with a naked eye, we think that this is going to help the model. It's uncertain how it's driving the results. But it's worth to highlight that it's also might be not necessary for the image of a autolet to be at the resolution that is sufficient for human reader. It might be that the CNN model, the convolutional neural network model, would still see those patterns even if we don't see those patterns at the resolution of the given image. So that brings me to the latest results. The latest run I have numbers recorded for. It's we have by now a little bit more pictures, but the latest run that I've done, it was done on 2,286 images. I keep in mind all those images have to always be separated into 3 sets. So one is the training set, then there is a validation set, and then the test set. The test set is used to assess the performance of a model after training, so providing an unbiased evaluation of its generalized capacity to assess new unseen data. So the trained set is the set that is used for training. The validation is used for verifying whether the new run through the model has improved the results or not. And then the test is used as a post after training verification of the results using when it's applied on the unseen data. So these are the typical splits. And we do the same. There's no point of using all autolets on training if you don't have any left for testing it on unseen data. All the images are resized to 400 by 400 pixels. Broken autolets are excluded. This resizing is driven by that the base model that we've been using. Currently, the models that are available, they're not designed for using very high resolution images. They need to be resized to smaller resolution just to be able to run it through this type of model. We do take images at a higher resolution, thinking about a potential future use when the computing capacity might be improving and we might be able to improve this type of models with the same images, just using different frameworks in the future. So they're automatically resized currently to those 400 by 400 images, but original images are about 2,500 to 2,500 by 2,500 pixels that we are taking currently in the office. In the current data set, we have images between 4 and 41 of Pacific output between 4 and 41 years old. And what we do, we train the model over 1,000 epochs with patients of hundreds. Here you can think about epochs as just the number of iterations that the model is running through. And the patients, the number of iterations that the model will run through. And if there's no improvement over that patient's parameter, the model will stop before reaching going through that 1,000 epochs.
What is the runtime like on this?
It's currently this model. It's between 8 and 10 hours. I would usually run it in the afternoon and be able to see the results in the morning.
For the training, but then application to new levels is pretty fast.
This is pretty quick, yeah. The use of the weights, because think about that, the epochs are those iterations, so it needs to train it through every single one, checks it if the new kind of proposed model is better. If it's better, it overrides the current results. If not, keeps them as is, and it runs through those up to 1,000 epochs. And then the learning rate, batch size, those are just model parameters, user-defined parameters. And then in terms of results, the results in training and validation, they are less important. We are more interested in testing results, but these are reported here. Just keep in mind that these results are for the normalized age. So to make the model run faster, we divide the age by the maximum age so that the variable that goes as an input is a variable between 0 and 1. So here we have age accuracy measured as a normalized age MSE throughout the training process. I can see the model was set to run maximum through 1,000 epochs. But it's actually the improvement occurs over the first 250 epochs. It runs up to about maybe 340, but with the patient's 100 means the last one, over the last 100, it didn't make any improvement. So we have in the model about, I think, 240 or so iterations where it was, it kept on improving.
Training kept on improving, but the validation seems to have plateaued pretty early.
And the validation is the one that is actually driving. So the training, it might be overfitting. That's not a problem. It is the validation that's actually looking at whether it's gonna override the results or not. So it is the validation RMSC that is actually driving the decision whether the new model is better than the previous or not. And it might be looking like a plateauing, but there might be very incremental improvements that will be still recorded as an improvement, so the model keeps on running. But certainly, the most training occurs over the first, I guess, 50 epochs. But these are the results. This is the plot of the model achieved comparison between the manually derived age with the AI predicted age. So on the x-axis, we have manually derived age, and on the y-axis, we have AI predicted age. As you can see, it's not great yet, but it is definitely aligning with that one-to-one line. It's keep in mind, we do not have many of older age categories in the training set yet, so it's hard to expect the model to be predicting the ages very well in that older age specific HAL. But we have achieved the RMSC in the test set of 1.84 years when this is calculated as a rounded result. So as I said, the results come as a continuous number. To get the age, we rounded those numbers, and for that we have the RMSC of 1.84. What it means, we have correct age predicted for 30% of individuals and additional 38.5 being within 1 year of error. Yes.
Can you just remind me on the manually derived ages, are these known age, and how do you know?
They're assumed within the model that they are known. There is some variation between the readers.
So these aren't like whenever those nuclear tests were done, kind of verified ages. These are just ones that are easy to clearly ageable. So there is error in the manual derived age.
So there would be still some error within the manual aging. There's no better way to we did verify with nuclear carbon that the method of manual aging is generally unbiased, but there is still some error between the readers. But within this type of models, you assume that this is the best. This is the given age. But what you can benefit here really is that circular framework, where over time you can look at which ultralights have been predicted with a higher level of uncertainty, and you can add that kind of specific image to, like, you can evaluate it again, right? So the circular framework allows you to reevaluate your training set as well, and go back and potentially verify some of the images.
Part of the reason I asked that is that you do account for aging error in your likelihood. How are these comparable?
These are less precise than the break and bake games. So I have the ability to have as many aging error matrices as we need. We have two in the models currently. We have one that represents break and bake aging, which is assumed to be unbiased based on the bomb radiocarbon validation that we did years ago. And it's relatively precise, more precise than this. And then we have a second aging method for some of our historical samples, which was based on surface aging of the otoliths, which is less precise and biased, and increasingly biased after about age 20. Fairly unbiased up until about age 20, but we estimate those two, the level of imprecision in those two methods is estimated through multiple reads. So we estimate the joint probability of being right, being wrong in your first read and right in your second read, being wrong in both reads. And that's, Andre Punt's got a program where you just basically put all of your double and triple reads into one platform or one data set and simultaneously estimate the imprecision and bias for as many methods as you want, with the assumption that you have to pick one and assume it's unbiased. Luckily, we have the bomb radiocarbon that validates our break and bake. But I mean, I think the takeaway for this is that we wouldn't expect this method to do any better than the original. It can't be more precise than the original break and bake imprecision. So if it's even approaching that, I think it's considered a huge success. And we're not there yet, but we're getting there.
And what's the idea that you would use this then to include a much larger sample of less precise ages in the assessment, or that this would replace manual ages?
Not sure we're quite at the point where we would have made that decision yet. In terms of the assessment framework, we'd sort of have to choose on a data set by data set basis. We can't really have two age compositions from the same source in the same year, and I suppose we could.
Just like you've got multiple readers.
Yeah, I suppose we could.
Reader.
Question would be weighting those appropriately. Certainly that's possible. Also, using some data sets using AI, some not, or having certain years where we would have AI based ages or not. I mean, from the assessment perspective, this is just another aging method. And as long as we can quantify the precision and or degree of bias, if there is any, I can use it just like any other aging method.
I wonder if you want to keep your on radiocarbon samples for the cross-validation here, so that you have a really good cross-validation of this method with sort of set. Because now this bottom SC of 1.82 is a combination of error in the manually derived ages and error in this predicted as manually derived ages. So you do the cross-validation on the bomb radiocarbon ones, if those really are quite precise.
There's variability in those too, though, because the calibration is against a red age there. So if you plotted bomb radiocarbon age against break and bake age, it would look better than this, but not on the same, or not perfectly on the
Is there a reason why it's difficult to read manually the ages of older fish? Is it because the otolith has so many rings that it's so easy to miss? Like,
Yeah, so generally the older otoliths will have the rings more compressed as the fish grows older. So it is, but here in terms of this specific model, we don't know whether it's actually more difficult for the AI type of model to read. It's more difficult to read older ages. We just don't, at the moment, we just don't have sufficient number of pictures to really train the model very well on the older age category. So it's, again, this type of model can be more of a strategically trained also on adding additional otoliths that are older otoliths, and that might improve those results more on the higher.
so you could take more specifically old otoliths and then train a model.
Yeah.
Yeah, I mean, that's one of the issues, right? If this is trying to achieve a good prediction accuracy overall, and old otoliths are rare in its sample set, there's no benefit to making a guess that it's old because it most likely isn't, without knowing anything about what the image looks like. It most likely isn't old because they're so rare in your data set.
So
That's correct.
Yeah.
And that's how I was getting I was trying to run this model also on sex, and at the beginning my prediction was all otoliths will be female just because the best guess it is a female. So that's how this type of model works on the limit, like not sufficient number of training input.
So a couple of things on that. The break and bake method does become less precise the older the fish get, but not horribly so. But for the assessment purposes, given the known bias in surface aging, those data sets all have a plus group at age 20 because they become increasingly biased after age 20. The break and bake ages in the current models I plus at age 25. So we don't need much resolution except out to age 25.
Which is great.
Which is not bad.
This looks
Yeah,
pretty
it's
good.
maybe a little bit biased between 20 and 25, but we have the option to choose an appropriate plus group. Obviously, if we have to pull the plus group down, we lose some information about M and about older cohorts, which there's a trade-off there. But we currently are not using information other than it as a plus group for ages beyond 25.
Curious how this performs relative to simple heuristics like otolith weight.
We do not collect the otolith weight. We don't weigh them.
But I'm still curious, is this better than otolith weight?
Done a bunch of work on otolith morphometrics in the past. I don't recall
Do that regression pretty simply.
There's males and females are quite different. Joan could tell us immediately why that didn't pan out very well. She's looked at a lot of them, but there's differences in thickness of the otoliths between males and females. Then there definitely are some differences as they get older. And we've identified over time, to make a long story short, we used to assume we could infer fish size from otolith dimension. And it turns out that broke down as we saw changes in size at age. And so otolith dimension, there's also some flexibility in the relationship there as well. Dimensions, so it becomes.
Yeah.
It hasn't panned out for us in the past.
I'm not suggesting
might be
we
worth
should
revisiting.
use otolith weight. What I'm suggesting is that the correct null model to compare this to is maybe not a flat line. Maybe it's really simple heuristics to see whether all of this training in AI does better than a simple heuristic. Like that's a small otolith, that's a young fish.
But what I would like to highlight, this presentation here today is really intended to be more of a proof of concept that this method is promising. I just want to highlight that the previous run that was done, it was done on 1,300 otoliths. And we had the RMSE of 2.11, and there was 22% correctly predicted age. So there is certainly a lot of potential by just adding the pictures to the training set. We are not there in terms of saturating the model with how much it can actually provide in terms of input only in the form of images. There's certainly potential for improvement with adding additional variables, but we are not there yet in terms of there's still, it looks like there's still a lot of room for improving the precision of the results just through adding images. We just don't have more images available yet. So this is currently work in progress. We continue taking images as we speak. And but you can see that improvement here in terms of just adding images. We went from 22% correctly predicted to 30 by adding 1,000 images. So think about this being proof of a concept. The things are looking in as the images do drive the results in the right direction, but it's the precision of this should be still potentially improving as we just add images even without modifying the model itself. So it should be treated as such. It should be all about this is the results based on the current set of results, nowhere near what we think we can achieve in terms of precision only by adding images.
I'm super excited about this. I think it's got a lot of promise, and my questions are more to get a sense of how it's what it's doing. Can you specify the objective function that it's using to train and improve? Because it might be that you don't care as much about some parts of this curve as others, and I think the assessment model might be the appropriate way to drive that, right? The assessment model can tell you what you should care about here in terms of where the error is, and it might be overall error as calculated by C, but it might be something else, right? It might be that you want to do really well on some parts of that. Can you adjust that?
So at the moment, I'm just trying the model and trying to present the results in different ways. So maybe I will also show. So this is the manual derived versus AI derived distribution. So at the moment, what my goal is really to see where the saturation point of the model is only with the images, and then get the more in-depth discussion with Ian to see what we can do in terms of reassess the model. Maybe it is true. Maybe it's we just want to have those images categorized and just drop the trying to estimate the higher ages and just put it in the bin of 25 plus, and that might be much better. We're just not there yet to really explore this type of further potential changes to.
I still didn't understand. Can you change the objective function that it's using to improve? Can you tell it what improvement means? Or is it hardwired that it's just going to be trying to maximize or minimize squared error?
Oh, yes. So within the model, yes, you can change the objective function. At the moment, it's the different type of function depending on. So the RMSE is the one that is typically used for the regression for the categorical variables. It's a different type of function typically used, but you can. That's a feature of the evaluation of the model more than actually. The most complicated part is that extracting the features of the pictures and trying to use that pre-trained model and train it on the new images. But the functions that the model is using, that is something that is written as like user written. So those objective function evaluation of the validation set how the new models are selected based on what criteria. So all of this is something that can be adjusted.
I mean, as this develops, you might spend some time thinking about that, talking with Ian about sort of what characteristics of error really matter for the assessment model. It might not be just overall.
Yeah, at the moment, this is something I'm just using mainly to see whether there's an improvement as we add pictures.
Sure.
So that's a very simple one that I can just say, hey, this is improving. It's still worth adding pictures. I would start to really have a really closer look at the model itself as we start to have that point where adding images is not improving anything.
it may be the case, like with adding older images, that if you just add images at random, it's going to get ever better at predicting young ages, which is where the bulk of the data comes from. Because if you want to minimize mean squared error, you have to be good where the bulk of the data is. It doesn't matter if you're good where the rare ages occur.
That's true.
So you might think about whether you change the objective function to account for the fact that you also want to be performing well at high ages, or if you have to sort of manipulate what you feed it to get it to do well at those high ages. Ideally, you don't want to manipulate it. You want to give it all the images, right? And just have it deal with that by saying, upweight the importance of not messing up with things beyond what you would just with mean squared error.
And I think overall, I think what would be interesting is really, and I think that's going to be the next feature of the model that I'm planning to implement, is it's also to get in this confidence intervals for individual autonomous. That's definitely the next step where I think this model will need to go. I think please stay tuned for the next meeting. Hopefully I will have more to show, but these are the runs that I could have done on the current set of pictures.
Could you just go back to slide 8 for a sec? So for this, I would recommend like fitting a power function to that, just to see what ideally a power function would, in a perfect world, replicate that straight line. Because I think the bias here could start quite a bit lower than age 20. Like that curve if you put a curve through that, it's going to start bending over like in the 15 range. And maybe that's a way to some similar concept of proving the objective function. So in that case, if you took some kind of deviation from that curve and of course and the diagonal.
Sure.
So on the, I mean, I know it's a semantic, maybe not, but this to me is machine learning. What is AI about it? Like, what is artificial intelligence about it?
Well, it is a deep learning application. So.
Which is part of AI or part of machine learning, or are they the same thing?
So deep learning is typically considered a subset of machine learning algorithms.
Yeah.
So it's
AI sounds better.
AI sounds better. It's definitely, if you
Better
want
than
to be
ML.
more
ML doesn't
precise,
sound-
I would say it's a deep learning application. That would be probably more accurate in terms of like where it actually fits within the kind of realm of AI applications, but it's typically, it is normally used as a very broader term encompassing.
It's really like so.
So just a little bit on just to summarize the conclusion. So in terms of conclusion, what I would like to just highlight is that the ongoing advancements of the AI technologies or deep learning technologies in the field of marine science offers considerable potential to enhance the efficiency of age determination. Preliminary results presented here suggest that this approach could serve as a promising alternative to the current aging protocol, which relies entirely on manual age reading. And also the AI is evolving rapidly, so adapting to new developments might further improve those results over time. So even with the same image input, we might get a better results as the models improve. And this is happening pretty rapidly now. So even running the same model on improved kind of base model would potentially bring us better precision. And we should always keep in mind that this is intended to be really an adaptive approach where we continue to depend on trained readers for capturing temporal changes, at least for some subset of autolens. And in terms of next steps, Definitely the first and foremost is increase the size of the training input library. Some of the most better performing models that you see in the literature, they use about I think 8,000 would be at least the goal for basic runs. We are at about a little bit over 2,000. And then create a database comprising of labeled images of otoliths both pre and post processing to conduct a cost benefit analysis of processing otoliths for using AI. So this year we'll be also collecting pictures of otoliths pre-processing. So just directly coming to the office before and taking pictures of otoliths before break and burn process, and compare how well these perform comparing to using the model that is based on broken and baked otolith, just to see whether we can what's the loss in terms of precision if we forego the whole processing step and just save the time and effort to allocate it.
So this is a separate project? You
So-
have to retrain the whole, do like a stand.
Yeah, so we would retry and we'll train the separate model on unprocessed otoliths and see how well it performs on the same otoliths that are the pictures taken before baking and breaking and after, and see what's the precision difference there, and see whether we can, if we decide that in the future we can only manually age the subset, maybe we don't need to process some of those otoliths. So this is something we'll be investigating, or at least starting taking input images for this type of research project starting this summer. The otoliths from this year this are coming.
What kind of resources does it currently take to do the otolith prep and reading? How many people are dedicated to that?
So we have currently the otolith aging team. It's 2.4 full-time employees that do the manual aging plus whole preparation of those otoliths. We have also a big help of helping with pictures. We have 2 interns that are also contributing to this project and also helping with the logistics of bringing the otoliths, helping preparing them. Also, it is quite a bit of work to have those otoliths processed, prepared, and all. But definitely the major resource here is really having people trained to age those otoliths manually. That's the biggest challenge where AI or this type of models could step in terms of just replicability of the results, at least for a larger number of otoliths.
So on the high end, it sounds like maybe saving a couple $100,000 per year.
Potentially. And the next, in terms of next steps, we talked a little bit about it, also incorporating in the model use of additional auxiliary data. So using spatial covariates for better age prediction. So whether the model will perform better if you add as this additional variable, just where the fish was caught. There are other items that could be added to the model as explanatory variables. This could be year collected, which could be used to account for variation between cohorts and prevalent environmental conditions throughout the age, the fish life histories. And also the collection date, which could provide insights into seasonal variation to the interpretation of the otolith age. So we have the time when the fish was collected, and spring otoliths or early in the season otoliths will have some difference comparing to those collected later. So that additional information for the model could improve the results as well, especially on those confidence intervals where it model is unsure whether it's the next age category versus previous.
You could potentially, certainly we can use that information to improve our estimation. It's not obvious that the AI will be able to use it to, because it's an interaction term there, right? Like if the season is X, then interpret the margin this way, otherwise interpret it this way. And that kind of complex logic doesn't always seem to get across with AI. I know I've done AI on video data for fish passing through a fish ladder. Every fish moves from right to left in the frame, which is upstream. Every piece of garbage moves from left to right. the AI couldn't actually use that information. So, so it's not completely self-evident that that will improve it. It depends on what algorithms it's using, right? So.
And again, this is something to explore as a potential way to improve them, although there's no guarantee in terms of things. Well, that's it in terms of my presentation, and thank you for a very good discussion. That's very helpful.
Yeah, I want to thank you as well for pivoting there. In the last meeting, we did actually have it as part of the 5-year plan, but we agreed prior to move it to what's 4.2. So in the September meeting, we're now going to move this into just a regular update on activities from Basha and her team. So thanks for pivoting. I think it was an enjoyable session. It was good to see the progress. Over to you, Chair. It's 10:30. Did you want to break for 5-10 minutes and then move into paper 08, the stock assessment?
Yeah, let's take 10 minutes.
Thank you. Okay, if we could just have the presentation for paper 08 up on the screen, please. Ian, do you need
Ian to presenter status? I can move things through as we go. And although we are a couple of minutes behind on the schedule, I think we'll have no trouble catching up in the next couple of sections. We did leave plenty of time for these items, and the assessment presentation is relatively light. Let's maximize it there. Okay, so I'm going to speak to the development of this year's stock assessment. This is fairly standard outline from what we've seen in previous June meetings. I'll go briefly through the timeline for the assessment process, the normal extensions to time series and software that we do. One new feature that I'm adding this year or proposing to add this year, and then I'll address the specific SRB requests and mention a couple of other topics. I will note that with regard to the SRB requests and the simulation, I'll speak to this more later, but it's sort of a 3-part thing there's a FIS design component, an assessment component, and an MSC component. We had to pick an order, and we're going to find there's a couple of topics that are going to be, any order we do it in, we're going to want to jump ahead to other pieces. So Ray will also be speaking to some of this, and as will Alan. So by the time we get through all 3 of our presentations, hopefully you'll have them. Okay, so just to reorient you, our basic stock assessment review process here is to do a full stock assessment every 3 years. So we did a full assessment in 2015, 2019, and 2022. So we have another one planned for 2025. And the full years are when we break everything down, reevaluate all the data sources, model structures, the approach to doing an ensemble, the whole works. So this is intended to be an update this year. Last year was an update, and this is another update. We, of course, can make changes as needed. If something pops up, if there's a new piece of information we have to get included, or we find an issue that we have to fix, we can always do that. But we have generally been fairly restrained in the update years. So that said, this is a good year to do some of the simulation work that was proposed, and I'll show you here in a few minutes. The first thing that I always do is starting the year is to do the time series extension. So I take all the 4 models, extend them by 1 year using the projected mortality limits. And that it doesn't change any of the model results. They're identical to last year's production stock assessment model. But this allows me then to start a bridging analysis where we can look at every change from last year's final model to next year's model, including the difference between the projected catch for this year and the actual catch when that comes up. So I can do that stepwise. So that's always the final step. So if you see these time series, all the models that I plot from June on out will go to the beginning of 2025, even though we don't have any data really to fill in 2024 yet. Just have found that's a really easy way to make a seamless transition. So there is a new version of stock synthesis, of course. It turns out that we were pretty current in last year's version, and there aren't any features that we use in this model that changed between the 2 versions. But I do keep up to date just because it makes things simpler when we do have to jump to a new version. And I always like to double check and make sure there isn't a hidden feature that got changed and was undocumented that affects our models. But thankfully, no difference this year. This also makes it easier to maintain all the output plotting and diagnostics. There's a bunch of different packages that piggyback that if you get out of date, that can be awkward. So no change to the platform itself this year. But there is a new feature that's available that was not previously there. And so we have time varying selectivity in these models. And previously we would take the average of the terminal 3 years of the model and use that as the selectivity for the projections. And that's not atypical for stock assessments, but when we think about these, we're really trying to do sort of a pseudo random effect where we're allowing selectivity to vary over time. And in a true random effects sense, you would always project that uncertainty into the future. So we can now do that in these models. And it actually makes almost no difference. There's a table in the document showing you there's like in the second decimal place, there's a tiny little bit of difference in fishing intensity. John?
Can you just remind me what the structure is of the time variation and selectivity?
Yeah, so we have several different parameters that vary over time. The parameter defining the ascending side of selectivity, and the peak of selectivity for male Pacific halibut. There's 3 parameters for each of the selectivity curves, and we allow the parameter itself to change over time so that the shape of the selectivity curve can slowly morph. And that's an iterative process. So it's not a true random effect. We're not estimating the variance associated with that, but we go through an iterative process where we solve for the variance consistent with, we could go back to the 2022 assessment. I wrote out the equations, but basically you account for the fact that the maximum likelihood estimate of random effects is biased because you're not taking the integral. And so you solve for the value of the variance that is effectively the variance of the deviations that you get plus the estimate of the variance of those. So the way it turns out is that the sigma that defines the variability is a little bit larger than what would be the MLE if you tried to estimate, because you're not doing Remel or doing a true loss approximation or something. So Grant Thompson worked it out years ago, and there's a couple studies out there showing that you get about the same result doing it with true random effects or doing it in this penalized likelihood with this correction on it. The hard part is that it's not true random effects, so it's just an iterative process. So it takes more work. It would be great to just do straight up as a random effect.
Is it an average with deviations, or is it a random walk?
It's a random walk. It's treated as a random walk, and the sigma defines the step between each walk.
And this is a little bit on the side there, but should we be at all concerned that there's dome-shaped selectivity that's time varying? Does that affect how quickly you can detect declines in the elements of larger age classes?
So I think yes, if we had all the fleets be dome shaped, but each of the assessment models has at least 1 or 2 fleets that is asymptotic, and so there's always a selectivity curve in all 4 models that is asymptotic, and then asymptote doesn't change. We might be estimating the left-hand side of that, but it's always asymptotic. And that way, we don't have that situation. I think that would be some problem. And so this feature, this is essentially, we were already doing this with recruitment deviations. We treat them similarly. We have sigma for recruitment. And when we're doing a forecast, we include uncertainty in recruitment deviations in the forecast period. This really is the same approach. And it's the standard in WAM or SAM or any of these random effects models. You would always extend your random effects forward. I actually was a little surprised when I put it in place that I didn't see a bigger change in uncertainty in the forecast. But then I realized we're actually exploiting at a pretty low rate. Selectivity is not varying that much, and I'm only doing a 3-year projection. So it's not too surprising that it's not having a huge effect, I think. But it's the right way to do it. And so I'm proposing that because it doesn't really make much difference, if we set it up this way going forward, we'll at least be capturing that. And if we run into certain conditions where it does start to have an effect, I won't have to scramble and put it in the model. Didn't see any evidence that it was costing anything in terms of estimation. And that's because there's no data in the forecast period. So you're always getting back 0 on the deviation or on the step size for selectivity, but you're propagating that variance along with all the other parameters. Again, if we were making a projection at high Fs or at for a longer time period into the future, this would be a bigger deal. Okay, so that's something that I'm proposing to add. It really actually has no effect really on the current model. But I think it's the right way to move forward. Okay, so that brings us then into the SRB requests. And there were really two avenues of requests from the SRB at the last meeting. The first was more general, and that was to basically just do some simulation testing on the stock assessment model and look at how it performed. And I think this was a useful exercise. So I'll go through the steps that I took. There's a lot of different ways you can set this up. I did the easier approach using stock synthesis, which is that it has a built-in parametric bootstrap feature. And the way this works is that you fit a model, and then you can automatically generate as many new data sets as you want that are unbiased relative to that model fit. They have the exact same dimension and the same precision as the original data. So all of the annual sigmas on your surveys and the sample sizes for your composition data, all that's retained, but you're resampling about the model fit that you got and creating new data sets. And then you can refit the model to each of those. And it's not a true simulation because you're using the same dynamics that you're fitting to. But it's equivalent of, in the SAM models, they talk about doing a self-test. It's basically a self-test. You just generate data that's consistent with your model and refit and see what it looks like. But to be clear, this is not creating a different set of population dynamics and then refitting this model that doesn't match in one or more ways.
And this is a logical step one.
Exactly.
The simulation testing model.
It's the basic first step to simulation testing. It also doesn't resample the underlying data from a data process. It's resampling about the model expectation. But nonetheless, I think it's a useful exercise. So I did this we have four, it's a little more complicated with an ensemble. So I have 4 different assessment models. So each model I used each model to create 100 new data sets. And then I refit each data set using that assessment model. And then I summarize them at 2 levels. The first is by individual model to see within each model, how is it doing to recreate the dynamics in that model. And then the second was to treat it as we use it for management, which is to take each iteration of all 4 models with a new data set and recreate an ensemble of that result, and then compare 100 ensembles to the ensemble of 4 models that we're getting. So that's actually the information that's being used by management. So it's not too hard to do that. I just had to feed each simulation through the ensemble aggregation that I do normally. And I will highlight this when I get to the figures, but I just want to make, there's a subtle distinction here, is that when I did the individual model comparison, I have the original fit and the 95% interval associated with parameter estimation of that fit. I compared the distribution of MLEs across 100 simulations to that. So that's not exactly apples and apples. It's more like coverage. But then for the ensemble, I created 100 ensembles, and I actually took the 2.5, 50th, and 97.5% interval for each of the ensembles. So at the management level, the management advice level, the quantities are exactly analogous. It's like having 100 ensembles. So I'll highlight that again when I get to the graphs. But the result of this was overall, these models are pretty close in terms of fitting, in terms of recovering the dynamics. They're not completely unbiased. Both of the short models overestimated the spawning biomass a little bit. So in these figures, the blue is the original model fit, and the red is the median of the MLEs from 100 data sets. And the band, again, the blue band is the 95% interval from the single actual model, and the red is the 95% interval of the simulation MLEs. So it's not the variance of each simulation. So the dynamics recreated reasonably well, although again, slight overestimate of spawning biomass for the 2 short models. Interestingly, the 2 long models, so this is the areas is Fleet's long model, and then next will be the coastwide long model. The two long models both underestimated the spawning biomass, at least toward the end of the time series slightly. So a little bit different pattern in the two. And I'll speak to why I think this is occurring in a minute. And also some differences in intervals here. You can certainly see in the 1960s, the range, there's probably more uncertainty in the models than we're capturing in the single base case, because the distribution of MLEs, that red band there, is almost as wide as the blue, and that's not the uncertainty of those models. That's just the distribution of MLEs. So it definitely, there's some interesting patterns in the time series here. This is the areas as fleets long time series model, and this is the areas as fleets. Sorry, this is the coastwide long time series model. This one's actually closer, although again, slightly underestimating the spawning biomass at the end of the time series. So then I took each of the 100 simulations, and they're independent. Each one is using a different set of random numbers. They're completely independent. So I could do the ensemble in any order, and I just took them in whatever order, one of each of the four models, and created the ensembles. And so this figure then is the distribution of, in blue is the base ensemble and the 95% interval for that. So that's the result of last year's stock assessment. And then the red is the median of the medians from 100 ensembles, and the 2.5 percentile, the median of the 2.5 percentiles from 100 ensembles. Because it's hard with four models.
It's getting,
putting
yeah, it's
them all
getting
together.
complicated, yeah.
And similarly for the upper confidence interval. And so I think my takeaway from this is that the estimate's pretty close given the amount of uncertainty. We use the point estimate is used for some of our management input, but then we're also creating the decision table out of the whole range of uncertainty. And this suggests to me that we might be underestimating the true uncertainty a little bit, but not terribly. And it seems like maybe some of that is on the high side. Also, interestingly, because we had a couple models that underestimated the spawning biomass at the end and a couple above, they actually come out to be less biased in the ensemble than any of the individual models, which I thought was interesting. Yeah, I mean, I guess that's the central limit theorem. But it's nice that it worked even with an N of 4. So again, this is a very basic simulation test, but it's a start. It's a look at self-testing of these models.
So your simulation, the uncertainty of the simulation is broader.
A little bit broader, yeah, especially on the high side. So if we did 100 ensembles instead of just one, with incorporating the uncertainty in the data itself, we would get a slightly broader. The range of uncertainty would be a little bit bigger than we get in with just one realization.
What's your overall take on this? Were you surprised that bias existed, or?
Actually, I'm reasonably satisfied. I think I have on my next slide. So I've done this exercise for several different stock assessment models over the years. And I think an important thing, because this is a self-test, we go through this data weighting process when we fit a stock assessment model that tends to remove most of the conflict among data sets, but a little bit of conflict left will manifest itself in a little bit of bias in these exercises. And had I generated a new data set and then reweighted all the data sets, I think it would have been more or less unbiased. This is useful because it says that there's probably still a little bit of conflict among the data sets in the existing models that I could explore a little bit more, either through adding additional process or through a little more data weighting. There might be some additional conflict that could be removed. But generally, I'm pretty satisfied. I've certainly seen models that did worse than this.
One of the things I can see happening here is the age comps. Simulated age compositions always look better than real ones.
They do.
So could you compare variance estimates from the simulated data versus the actual? Because we did this recently for questions about age composition sample size. So we had to look at the variance relationship of the age composition to the sample size, which ended up getting a lot more complicated than we initially thought.
Yeah.
But they can be way off, like they can be really different. So when you do a simulation like this, yeah, it looks great. But actually, if you look at your simulate, it's because your simulated data are all coming from your assumed distributions, right?
Yep.
And so they're all perfectly distributed. So your iterative reweighting is probably just flying through that stuff, right? Because it's all lining up nicely.
Well,
with
I'm
the
not
assumptions.
doing the reweighting on each simulation. So that's part of why I think there could be a little bit of bias. We do the reweighting in the original, and I think if you were to get it perfect, these models would generally be unbiased. But there's probably a little bit of conflict left there. By bootstrapping the effective sample size before we put the data in and then doing the iterative reweighting, we should be getting in the ballpark. But you're right. I think that's exactly the sort of thing that goes out here. This self-test generates data with exactly the same properties that you put in. So if I put in an age comp and I say this has got a sample size of 20, then that's what I get for each simulation. But if the effective sample size is exactly 20, and it should be close because it's tuned in the original, but any little difference there can create differences downstream.
Yeah, I mean, an effective sample size of 20 from the distribution that you're assuming. So the thing is, the real data are probably not exactly that. So you do end up getting quite different looking things even.
And
You think you've got a low sample size and should.
any patterns in the residuals
Yeah.
disappear when you do the bootstrap, and so they manifest in a slight bias. So generally pretty satisfied with this. What it does, and this was a good first step for the next step, looking at FIS designs, because what this does say is that I want to be really careful when I'm doing a FIS design test to only be testing the effect of FIS and not these other factors. So and you'll see what my proposal for doing the FIS design testing is to do this and use that as the truth, the central tendency of a set of bootstraps as truth, and then compare different experiments using FIS designs so that we're isolating just the FIS and we don't confound it with other things that are creating slight differences in here.
Have you ever tested senescence in the model? Because some of the figures show quite some sort of bias that the simulated sporic stuff biomasses are higher. So could that be explained by the fact that there is senescence present?
Senescence.
So older individuals start to have an increased mortality.
To the degree that we have, I wouldn't say there's strong evidence for senescence here. We certainly have patterns in the residuals. I could go back and look usually in the full assessments, I do all the residual plots and things. But I don't think we have a systematic issue with residuals for the older fish across all data sets. We tend to have them in certain data sets and others. The real challenge, I think, here is not necessarily senescence, but spatial dynamics. All of these models are not true spatial models, and we have spatial dynamics going on. This population doesn't mix perfectly. And we get a little bit of, we explain a little bit of that with the areas as fleets, but it's not the same as doing a full spatial model. So I think that the residual patterning and the residuals we tend to see, I would generally attribute to spatial patterns that we can't fully replicate because fish are moving between areas, and we're approximating different regions by different selectivity curves, but those relationships change over time, and so even time varying selectivity doesn't capture all of that. We did, as Sean will remember, we did spend a number of years trying to get a full tactical assessment model that was spatial up and running, and it's harder than we wanted it to be. It turned into the operating.
It's easy in theory.
It turned into the operating model for the MSE, which is much easier to condition and parameterize than a true tactical model. But maybe we'll get there someday. So a first cut at some simulation work that I think was really helpful in understanding, and then also setting the stage for the next set of recommendations, which was to focus in on the FIS designs. And then, you can read it a little bit here. Here, I've just pulled together, you'll recall from your fall meeting that you made a number of recommendations about FIS designs. And these really span the space-time modeling approach, the stock assessment, and the MSE in terms of what we need to do to address all of this whole output. So I think rather than go through and read these back to you, I'll show you what we did, and then we can look back to these maybe at the end and see what we've covered or what we're proposing to cover. What we're proposing is a three-phase approach. So when we get to the space-time modeling paper, which is paper 6, you'll see that we've done a range of different projections and generated estimates of future CVs for the index of abundance from the space-time model that represent different FIS design options in the future. Those are projected out 3 years. And so that was kind of phase 1, was to determine what are these different designs going to do for our FIS data over the next 3 years. So you'll get that in paper 6, and this is the sort of order of operations here. You'll get the detail there. I'm not going to recreate that here. The second phase is then to take that output from the space-time modeling and use that as the basis for a simulation experiment using the stock assessment model to evaluate three main questions regarding uncertainty in the FIS index and how that affects things, and the potential for bias in the FIS index and how that's going to affect things. So I'll step through exactly what I'm proposing there in the next few slides. But before I do that, I want to note that then the results of this analysis using the assessment will be the components that Alan will need to do a similar thing, feeding us through the full MSE. So we're sort of stepwise. First, we're simulating using the space-time model, then we're simulating using the stock assessment, and then using the results of the first two phases, we'll be able to close the loop and get what people really want to know, which is how does this affect the full management loop at the end of the day. So we have for evaluation, and Ray will go back through this, and he's got maps of these as well. But just to orient you here, we're evaluating 3 designs going forward. What we're calling a base block design, which is basically doing the whole survey but rotating chunks of the coast over a 3-year period. And the key to this design is that this is going to be an unbiased design because we're sampling everywhere over a 3-year period. We're not going to leave no place will go unsampled for more than about 3 years. And so there's really no opportunity for substantial bias to creep into this design. Even though it is blocked, we're using a geostatistical model, and so we take care of that. The second one is a core design where we're sampling basically over the center of the stock's distribution, and we won't be doing sampling on a frequent basis at the ends of the range. Again, I probably could have drawn some of the maps. Ray's got maps for all these in his presentation. But the important takeaway here is that this design is going to be more uncertain and has the potential for bias to creep in because we won't be frequently sampling at the ends of the range. It'll also create gaps in the stock distribution estimates. The third design that we're looking at is what we'll call the reduced core design. And this is effectively what's being launched right now while we're speaking. This is stripped back all the way to just areas that we can pay for, basically. It's going to have more uncertainty than either of the other 2 designs and an even higher likelihood of bias. So I'm structuring the assessment simulation around these 3 designs. So here's my proposal for how to do this. And again, it's sort of springboarding off the assessment simulation that I just showed you. So the first step is to extend the time series out so I have a 3-year projection period. So we capture the full range of these. We thought it would be useful to, even though we're on an annual management cycle here, we thought it would be useful to show people where we are likely to end up at the end of 3 years, just to illustrate how these designs are going to vary. If we do this only on a 1-year basis, it really doesn't get at this question of what if we're stuck in this rut for several years at a time. So then I need to define a true model. And to do this, I'm going to use the output of the space-time model using the base block design, which is the unbiased design, to inform these models. So basically refit the model with data out to 2027. And I can generate the data for everything but the FIS and then add in the information, the CVs appropriate to each of these designs from the space-time model. So then I have a true model with an unbiased FIS index. Then I can refit that true model with no trend. So we're just capturing the bias. And then I can also add in true trend in the FIS. And we've chosen 15% because that seems like something, a level of bias that could creep into these designs over a 3-year period. Again, you'll see more from Ray on this. So we can refit models with both a 15% positive and a negative trend. From these, then I can bootstrap new data sets. And again, this is by ×4 models. So this is quite a lot of combinations to do this. There's a table that tries to lay some of this out in the document. Bootstrap 100 new data sets for each model and each trend. So now I've got the truth basically laid out. In when I refit those 100 models, I've got the actual result. I'm proposing 3 experiments. The first experiment is to isolate the effect of just the increased CVs. So here I use the true data fit to the bootstraps from the base block design with no trend. So there's no trend in the survey. There's no bias included here. But what we want to know is what's the effect of the increase in CV over the next three years. And so the CV will go up on the index, and we will have we'll also have the associated age composition data, which will be reduced in proportion to our sample. But again, there's no bias in this first experiment. We're only looking at the effective variance. We'll assume that all the other data sets are sampled or continue to be sampled in the same way. So the fishery data will have the same sample sizes, the same index on the CPV series. So the question we're asking here is, how does a reduced but unbiased FIS affect the management quantities? And we'll take this all the way through from 4 models all the way through to the ensemble, and we can look at the bias, potential bias, if there is any, in fishing intensity, spawning biomass, and the risk of stock decline, to boil it down to 3 things that we'll always look at from the ensemble. So we'll know the true SPR. What is the SPR that we get as a central tendency of 100 bootstraps? Same thing with spawning biomass, and same thing with the risk of stock decline. And that last one is one that people have really been focused on the last several years. The decision-making process is really boiled down to trying to select a catch level that makes the trade-off between yield and not having too high a risk of further stock decline from where we're sitting right now. So that's experiment 1, no bias, just the effective variance. Experiment 2 would be failing to detect an increasing trend when there actually is one. So we have these design reductions. We know that bias can creep in because we're not sampling everywhere. And so the true data will have a 15% increase. But when we bootstrap, we've also fit models that don't have a trend. I'll use the data from the FIS for those bootstraps, and I can cut and paste from different bootstraps and take the no trend. And so the FIS will be biased, but the fishery data will be unbiased. So there's some of this trade-off between the data sets. We'll see how much difference it makes. And then we will, we're basically, with this experiment, we're asking the question, how does the reduced and biased FIS affect the management? So we have an increased variance, but the FIS trend is actually biased in these bootstrap data sets. And again, we'll take it all the way through to the full ensemble. And then, of course, the third one is the inverse of this, would be failing to detect a decreasing trend. And this is probably the one that'll be of the most interest, because presumably we're going to underestimate the risks of stock decline. And the question will be how much, and how does that compare across the reduced core versus the really stripped down design. So we'll be able to see incrementally those three steps.
And this bias is overall bias for the whole stock region. So presumably it implies that you've got stronger bias in the unsampled areas. Since the core is unbiased. I mean, I know the spatial dynamics all get compressed in the assessment. But
Right. So that would be the assumption, is that this bias is coming from the unobserved areas and the sparse coverage, even within the core. And so the arbitrary piece of this is a 15%. We have to pick something because we don't know what the true bias will be. We know that it could 15% is plausible, and you'll see some of the information that Ray's got with different CVs. It seems like 15% is a place to start. in the coastwide models, that just cooks down to just bias in the coastwide index. My first inclination is just to use 15% in each of the regions in the areas as fleets models, just to keep it simple, and reduce the age compositions in proportion to the amount of sample that's going on. So reduce the input sample size to mimic the additional loss of age composition data as well. The age composition data will be biased here because I'm actually I simulated the truth, right? So, and then I'm using the age compositions associated with a flat trend versus an increasing or a decreasing trend. So I'm actually simulating biased age composition as well as biased index.
So sorry, the 15% is cumulative over the 3 years or annual?
My proposal was to have it be biased by 15% at the end of the 3-year period. So the cumulative bias, yeah.
Do you think it matters that you're applying that to all areas equally when in fact sometimes the big bias compared to the edges?
Well, you'll see from the maps, I think it's possible we could have some bias in the core as well. These designs are sparse enough that I've got some concern there. Maybe it's not 15%, but if I have,
that it's really high.
if I have time, we could get more sophisticated with this, but as a first cut, really the results of this are going to be helpful to inform sort of the interpretation of the assessment, but they're going to be especially important to also feed into the MSE and to help to parameterize how wrong is the assessment likely to get for a 3-year period. As you'll see from Ray's presentation, some of the areas like 4B is going to have a CV of 40 or 50% by the end of 3 years. Other areas are going to have a smaller CV, but there's still the potential for bias if we have heterogeneous spatial dynamics, even with a fairly small CV. So really the arbitrary choice here is the 15%. Is the biggest of choice, I think, but it's a place to start.
Yep.
And even though this seems pretty simplistic, this is actually going to be a fair bit of work because I got a bunch, there's 4 models, I'm generating 3 different true scenarios, and then I'm mixing and matching to create all of the bias things. This is quite a few different simulations, and I'm going to do each one at least 100 times. So it's going to be a bit of work to set this up. That's why we felt like it was important for you to see the space-time analysis first, and then see this proposal so that we're a little closer when we actually run this thing, and we don't end up just doing this several times to get everything coordinated. I want to highlight one thing here, which is that this is going to be a great exercise, and it's going to really help inform management, but it's missing probably the most important part of this process that we've learned over the last couple of years, which is that if we go to the annual meeting and people don't have confidence in the survey index, it derails a lot more than just the CV of the assessment index. This is a critically important piece. We've seen this play out over the last couple of years, where we actually saw, I reference it in the paper, we saw a regulatory proposal to freeze any increases in catch for areas that don't have a survey in a particular year. That was a stakeholder proposal last year at the interim meeting. And that just sort of underscores the kind of lack of confidence people have, even though we have a space-time model and we can say, look, based on the temporal correlation, it's not likely to have changed by more than this amount. That doesn't cut it in the management realm.
What's the factor? Like freezing the catch? Maybe a worse or a better thing to do if you don't have information. Like, what's the law?
Right.
Is it a penalty? It's not their choice.
I think that the thinking was we shouldn't ever increase the catch unless we have direct evidence that should happen. The problem is that if you have a coastwide TCY and you're doling it out and you freeze one area, it ends up somewhere else. So it didn't go anywhere. But I bring that up as an illustration that people's confidence in the survey, far and beyond any other data set that we have, is critical. And I'm a little bit worried that as we go down this highly quantitative simulation road, that we may lose the sight of the fact that we can simulate and even if we find in the MSE that, hey, we could get away with this design for 3 years in a row and it wouldn't have a huge effect on management, it's going to have an effect on the management. people are going to show up at the meeting and confidence is going to be low and decision making does get affected. Unless, I mean, maybe this gets back to our first discussion as well, but unless we're locked into a management procedure, this sort of thing definitely feeds into the annual decision making.
I mean, it gets to the same point of being confident in a single data point versus being confident in the process.
Yep.
You know?
Yep.
If you're confident in the overall process, you don't have to be confident on individual data points. Just as long as you know your process is covered.
Yep. But, you know, we have this, our survey, because it's a cooperative survey, we charter commercial vessels. It's people buy into this survey. This is, as much as in a normal year, as much as we get complaints about the survey and there's always argument about what it is and isn't showing, what we've learned in the last couple of years is that when it's not there, there's a lot of concern about what do we really know without this survey index.
It's not illogical for someone in one of the regions outside the core to say the survey hasn't been here in years.
Exactly.
And I have no confidence that it's correctly capturing dynamics in the areas where I fish.
Exactly.
But that's reasonable. It's relying very heavily on that spatial autocorrelation, spatial and temporal autocorrelation at that point.
Yep. Yeah, and even though we don't have evidence in the existing time series of rapid change, you know, we're estimating the temporal correlation coefficient. So the confidence interval should be unbiased, but that doesn't mean, you know, we're not at the top or the bottom end of that interval in a particular year moving forward. So anyway, I put this in as a caveat because it's sort of outside the quantitative framework, but it nonetheless, I guarantee this is going to be very important moving forward. Okay, so I'll pause there because that's the proposal. There's a little bit more detail. There's a table that lays out these 3 experiments in the document, but that's really the proposal for the first step of simulation of FIS designs using the assessment. And we can have some discussion now. We can also wait till you see Ray's work and get some maps. I realize it's a little hard to picture some of these designs without the maps, but and I think Alan will also speak to how this is going to potentially feed into the MSC later on.
I think this is good. It's a really good start. Initially, it sounds, as you said, like self-test is really basic and simple, but it gets complicated quickly. But I think you've covered some things people should be concerned about. Probably are concerned about. Hopefully, when it comes to producing results and communicating those results, you know, you can deal with this issue of confidence in individual year observation versus in the process. And part of what you're doing, you may show that, you know, things may get more risky, as they should. The worse things are. But you know, it's not a black and white thing, right? Confidence is not a black and white thing. It shouldn't be. Nobody should be 100% confident in anything or zero. Just because the survey hasn't been in your area for 3 years doesn't mean your confidence should be 0. And you're giving them information about that.
This may actually strengthen the argument, like you're saying,
Yeah.
for focusing on the process rather than the data points that we've got sitting in front of us in any particular year. That said, we have a long history of focusing on the data points in front of us every year. And it's how the commission, you know, the results of the survey are the crux piece. Sure. They're the keystone of the whole thing. People need to believe the survey. So until we have some better financial stability, whether it's created by change in the stock price or whether it's created by some level of supplementary funding that allows us to get a baseline done every year, regardless of cost. Until we have that situation, I think we're going to have a pretty big challenge. I'm, to be honest, not looking forward to this year's annual meeting because the results are going to be more or less as reliable as we've seen in the past. But I think people's confidence in them is going to be lower than we've seen in the last couple of years because we're doing a pretty sparse survey design this year.
And as much as theoretically confidence might be a continuous quantity, in practice, it's not. People either trust the data or they don't.
But we're already getting feedback of people concerned about they're seeing trends in areas that we're not saying. If we see things in a small geographic subset, how do we know that that's extending out? So
But it extends to other things like, which I've always dealt with. Talking to our group in Halibut is, their fishery CPUE is doing things that's different from the survey. So they don't have confidence in the survey for that reason.
Right.
So if you don't do a survey and your fishery CPUE is going down and you're like, I think the more you talk about these things, maybe the more people just back off the black and white kind of assessments of things.
it's true. They're learning to live with this situation because we're now in the second year of somewhat reduced survey. This is going to be a third year. And as you point out, we have seen both quantitatively and qualitatively, we're shifting our emphasis from the survey to the fishery information when we have a sparse survey, whether we want to or not. Both data sets are in the model and both things are in front of people. So we did spend a lot more time last year talking about fishery CPUE than we have in past years. So that's a natural shift. The challenge is that there are a lot of reasons why fishery CPUE changes, and not all of them are related to the population.
Yeah.
In British Columbia, in the last few years, they've spent a lot of time trying to avoid several different choke species, and that's affecting CPUE. They also have new MPAs going in, which is affecting CPUE. And so there's, for all the reasons why we have the survey in the first place, it's not a discussion. Anyway, we might be beating a dead horse here, but I do think this is outside the quantitative part, but an really important part of the halibut process. So I'll go on, and then I'm happy to loop back to any of this as we go through the other presentations as well, if it helps to put this in line. I only have a couple more slides, and this is really just to put the rest of this year's timeline in context for you. So as you'll recall from previous years, we have this June meeting, and then I've got basically the summer to do for this year. It'll be to do this simulation testing for the FIS designs. At some point between now and September, I will likely get the 2023 sex-specific fishery age composition data, so that'll come in. And then potentially, after you see Colin's presentation, I'll also be doing some exploration of the new maturity results in the stock assessment. Hopefully have that in time for you to see in September. Then in September, we have another SRB meeting where we'll present the results of any requests you make from this meeting, plus the things that we've proposed to do. But then after that September meeting, that's really where we need to lock in what the assessment's going to look like for this year, because we really don't make model changes after September unless things really got off the rails for some reason. The data sets, the final data sets roll in during October. We finalize them on the 1st of November. And then it's really about 10 days until we need to have the full assessment done and start producing management results for the commission, for the IM in late November. So because of that tight timeline, we don't make changes after the September SRB. We basically agree this is going to be the framework and stick with it. The caveat being there, if the wheels totally came off the bus, we'd have to set up a conference call and we'd figure out what we had to do. But in the 10 years I've been here, we haven't had anything break to the point that we needed to pull the ripcord. Just to highlight that basically the next couple of months are the time to do more R&D and get things locked in for the assessment. So my presentation's done. The recommendations here are just to note this paper and the response to the previous recommendations. If you have ideas or additional modifications to the proposed FIS design simulations, that's really the priority right now. The stuff that we've done with the space-time model is hopefully largely done. This would complete the assessment section, and then we pass that on to the MSE portion of that. Obviously, we're interested in the results at each stage as well. And then anything else you may recommend for the fall meeting for us to produce for you. That's it for my presentation.
Okay. Let's just move on then.
Jump on to management strategy evaluation PowerPoint. I think it's paper 7, is it? Paper 7.
Yes. If I could be made a presenter, I can control the slides from here. Thank you. Okay, I will talk about the MSc program of work for 2024, which is a lot of that is guided by past SRB requests and recommendations. But we also had a MSAT meeting in May of this year. And we had an intersessional discussion with commissioners that on June 3rd, I think it was, that also provided some clear guidance on the path of the MSc work this year. So I'm going to start right off with what we're talking about this morning, and that is related to this SRB request, paragraph 30, talking about the coastwide scale and separating that distribution component from that, and just calling that a negotiation process. And so this is what you were mentioning this morning. This should make this management procedure a little bit more easy to implement and investigate in the near future, at least. So we're currently revising a draft harvest strategy policy. And what I wanted to show here is that there's this coastwide scale, and we had this TCY distribution. And what we're doing is just blanking that out and putting it all into the annual decision-making process as a negotiation step. And in this last week, I've actually been working on this figure, and we've redesigned it to really show that process where the allocation or the distribution falls into the negotiation of the decision-making process at the annual meeting. So I think this will make it a lot more clear exactly what we're focusing on, what the management procedure would entail, and that's the coastwide TCY aspect. So we have not presented this specifically to any of the other subsidiary bodies or the commissioners, but I think that they will, everybody will certainly appreciate this update. As part of the harvest strategy policy, and something we've been working on with the SRB and the MSAP for quite a while now, is the definition of exceptional circumstances. What are some exceptional circumstances or things that happen, actions that happen, or well, things that happen that would define when to open up the MSE process again? And that would be potentially, looking at the operating model, re-examining management procedures, et cetera. And so we've been, this is probably the third time we presented these, and the wording might be tweaked slightly, but we've come across three sort of concepts that would define an exceptional circumstance. One, looking at the coastwide all sizes FIS WPUE or NPUE and comparing that to the MSE simulation outcomes. Two, looking at the estimates of stock distribution for any biological region, comparing that to the simulation outcomes. And then the third is just taking a look at what has been learned recently, what new data sources are available, or what new concepts are now understood, and potentially reopening the MSE simulations if something is very different. An example of that would be the updated natural mortality when the third of 4 ensemble models estimated natural mortality. We redid the operating model and made sure everything was in sync with the assessment model, at least those assumptions. Yeah.
Just giving a little more thought to C. If natural mortality was at its 95th percentile, I think that would cause a bit of a stir.
Mm-hmm.
So I wonder if something like key parameters, you may want a tighter tolerance.
Okay.
I'm not sure that.
Yeah, no,
Yeah. You could have a pretty major effect on your simulations from much smaller changes.
And maybe we just, we'll think about potentially some wording there and see that, I mean, do we even need the percentiles there? Can we word it some other way?
You don't want it too vague.
I know.
You don't want to say
Yeah.
change substantially, which is,
Mm-hmm.
you know.
Okay. Yeah, if the SRB has any recommendation on that, it would be gladly accept it.
What about making it tied to the percentiles rather than tied to sort of flat percent change? Because the percentiles, if your uncertainty going in is really large,
Mhm.
it would take an enormous change from the point estimate to trigger this.
Mhm.
So you might have like a threefold change in the point estimate, still be within those percentiles.
Right,
if it's
right.
poorly defined.
Right.
This might be something that we recommend in the next round of simulation work, maybe is to, on some key parameters, test them in your simulation, right? You're doing a 15% change in bias in the FIS, try a 15% change in M, a recruitment parameter, to see where you get a bias in the short term.
I mean, I think C was written with the 2.5, 97.5 being pulled out.
We were
Yeah.
anchoring
Yeah,
on the
yeah.
previous
That's
one.
there. It might be that that's not the best way to define C.
Yeah, and we've had discussion with the MSAB and commissioners about exactly what C meant, and it's pretty clear that I have figured that out in my mind. It is a bit vague in that sense, when it would really be reopened. Given those, what I wanted to do was actually run through the tests of A and B and show you those results today. And so what we decided to present here is the comparison of the MSE simulations to the coastwide NPUE. And what is shown here is some historical values that the operating model was actually conditioned to. So up to 2022 was data used to condition that operating model. And that's the gray band. And I'm showing, I think, the 95% prediction interval and the 99% prediction interval. The yellow dots are then the actual observations of the coastwide NPUE from the space-time model. And those do not have the uncertainty shown on them because the prediction uncertainty from the space-time model is included in the bar plots from these. So I'm looking at the MSE simulation. I take one trajectory, say I'm calculating it for 2021. I simulate that 100 times given the observation uncertainty to show the range that the MSE would be expecting. What's shown in dark blue is then the prediction, the 1 year ahead prediction. Now that we have observation for 2023 from the space-time model, that was not used in the conditioning process of the MSE. So the dark blue is the prediction from the MSE and the yellow dot is that new observation. And that shows that it's within that interval. So we theoretically would not call it exceptional circumstance. What I've decided to use here for this comparison of an exceptional circumstance is the current interim fishing intensity, the SPR 43%. Even though the commission has reduced the fishing intensity, reduced the TCUIs, that's not what we're testing. We're testing a management procedure, right? And so we want to use that management procedure we're testing. So I'm not using what the commission actually chose, but I'm using what we would call the interim management procedure. So that one looks pretty good.
Now,
Sorry, go
Sorry.
back. Yeah.
just to clarify, maybe this, just to see if we're on the same page.
Yeah.
If you're in this cycle where you recondition your operating model, test the management procedure, and now you're using the management procedure, and as part of the annual process, you do your exceptional circumstances check, you do this thing.
Yeah.
Your projection base stays the same. You're not reconditioning your operating model every year,
No.
projecting 1 year ahead.
No.
You're projecting for the entire period you're going to use this.
Yes. So if we have a 5-year process where we're not reconditioning the operating model, next year there'll be 2 dark blue bars here, and then the following year will be 3 dark blue bars, and those dark blue are indicating projections from the MSE model. And if one of those yellow dots is outside of the dark blue area, then we would further go down the road of actions, which I'll present shortly. And you showed that at the annual meeting. You put we showed a very similar plot to this, and you put a dot outside of the blue to show the commissioners what would then result in an exceptional circumstance. So the part B of the exceptional circumstances is relating this to the proportion of biomass in each of these biological regions. So I've basically produced the same plot here. I've extended the time series back a little bit longer to give some historical context. And then I've done that for each biological region. And what should pop out immediately to everybody are there's a couple of yellow dots outside of those dark blue bands. And so the operating model is conditioned to the proportion of biomass in each of these regions. So these yellow dots on the gray blocks is what is actually used to condition to. So that's why I wanted to include some historical context, is how well is the conditioning process actually doing and explaining these data. There's a lot of variability in that. And you can see, like in region 3, there was a year there where the operating model just could not match that data very well. And we ended up conditioning it with that data point out, which these are 95% confidence intervals as well. But although I'm showing the 99 too. Now what's happening here is you see, okay, maybe the operating model is breaking down in its distribution of spawning biomass, or this is actually FIS all sizes biomass, in that it's now not predicting as much biomass in region 2 and is predicting more biomass in region 3. So it doesn't seem to be moving enough fish from 3 to 2. And what talking with Ian this year, Ian has actually looked at the PDO, and they've updated the PDO index, I think, in the recent year. Is that right, Ian?
There've been a few different changes.
Okay.
Yeah, but
Yeah. What the end result is that in last year's assessment, I believe it was, he re-identified a few of the most recent years as low years, positive PDO years. So there was a regime change, which is not captured in the operating model because that occurred before last year's assessment. And looking at that, yeah, it switched from one to the other, whatever way it switched. Yeah, it went from 1 to zeros. And what happens in the operating model, we're estimating movement to be dependent on the PDO, is that in a negative PDO, there is actually more movement from 3 to 2. So my theory, and I haven't actually tested this, is if we were to go back and recondition the operating model, it would, and put in that new environmental regime switch, it would probably begin to match these observations a little better. So it's an indication that the operating model potentially is not distributing the biomass correctly.
So this is a good,
Yeah.
and it's a good to have this
Yeah.
the outcome right now,
Uh-huh.
because yeah, you can kind of discuss the implications and things of it.
Another
First, whether you
yeah.
chase it,
Yeah, exactly.
right, and start modifying models and jumping on it, so that's option 1. Option 2 is just wait,
See what happens.
what
next year.
happens. Option 3 is this might be exactly what we're talking about by separating TCEY and distribution, because now maybe the discussion at the annual meeting is, should we respond to this in the catch distribution?
Mhm.
So there's different ways of handling something like this, that maybe you need a couple of these before you can, once you show it, they're going to come, it's going to become an
Yeah.
issue, right?
Yeah.
In negotiations.
Mhm.
So maybe just recognize that, and let it happen.
Yeah.
And do nothing.
And when the operating model was conditioned, when the operating model was initially developed, we really put a lot of weight on conditioning to these proportions because at that time we were investigating distribution procedures. So now, with the weight and the management procedure being really coast-wide, the coast-wide index matches really well to the MSC simulations. And now we're here. And like you said, Sean, maybe this has to do something with separating those two processes where this is something we may not want to chase it, but it may become something that's noted in the negotiation process as well. And I also note we have, in region 3, we have this exact observation occurred and then subsequently corrected itself. The MSC just couldn't explain that 1 year. So, I think too, this is a great example. I'm glad it's actually occurred, and it's something that we can hopefully learn from.
It might be a situation where we need to revisit that 2 years in a row criterion for
Mhm.
generating exceptional circumstances. Maybe 2 years is too low.
Yeah.
We're persistent with that.
Yeah.
I don't think a ton of thought into that 2 year.
No,
For this, because we said 2 year on the FIS, which is probably good.
Yeah.
Because that thing should be quite stable, but now you're getting into the nitty gritty of
Mhm.
spatial stuff. So yeah, you should expect more than 2. You could kind of see it coming too. Like there's a bit of a trend there. It's going. But and you can, if you're dealing with it in terms of the catch distribution, maybe you can afford to let it run
Mhm.
until you do things.
Yeah. Yeah, if we were developing specific distribution management procedures, this may be more concerning. But since we're not, we're more concerned on the coastwide, maybe not. And I think that 2 year was developed, the main concept was that there is a persistent sort of bias or that we're seeing.
But with a random walk, having 2 years of deviation is not that much more unlikely than having a single year.
Yeah.
I mean, it would be very, very different if these were IID.
Yeah. Oh, yeah. Yeah.
Then 2 years of deviation, that's
Yeah.
wake up and do
Yeah.
something.
Yeah. Definitely. So, yeah, and then bringing in concept C from the exceptional circumstances and the updates in knowledge. This slide shows that maybe a little bit more thought can be put into this and defining what actually means an update in knowledge. And so we put a couple examples here. And the first two, I believe, we'll be discussing at this meeting: stock structure and maturity at age. We'll see. We're collecting new data, new analyses on those. Maybe we have a total new paradigm shift that we need to discuss as a reconditioning of the operating model. But some other things to keep in mind for the future are fecundity, movement understandings, better understanding of recruitment, environmental drivers. Those are all part of this knowledge base that we're, putting a lot of assumptions into the operating model that are based on our current knowledge of this. So I wanted to point out some discussions we had at the MSAB. And we discussed these exceptional circumstances with the MSAB, and they felt pretty good about it, but they made one request, and I put in the note before it just to give a little background. And first, the MSAB noted the FIS is conducted a measure of population, and it may not be an accurate depiction of the fishery. And that the fishery-dependent data may provide insights into fishery concerns. So where's the fishery concerns coming in terms of these exceptional circumstances, in other words? So they requested that the SRB and the Secretariat work together to potentially consider different ways to incorporate fishery-dependent data into an exceptional circumstance. Now, we had that conversation with the MSAB that exceptional circumstances should be entirely based on observations, not model outcomes, but they felt, and fishery-dependent data are definitely observations, but they felt there might be some extra information that the stakeholders, the fishers out there may see something that's different than the survey. For example, catch rates are declining faster than the survey or something like that. And they have a concern about that. Since that MSAB meeting, I have not put a lot of thought into exactly how to incorporate fishery dependent data, but this is a request out there that I want to make sure that the SRB is aware of.
I can't remember, does the MSC project the fishery dependent indices?
No, not right now.
Because I mean, this exceptional circumstance, as we've been discussing it,
Yeah.
it is a mismatch between the model projections and observations. And so if we're not projecting fishery dependent time series, how do you have this mismatch?
Yeah, exactly. And so that would be a part of it, is then to put in the fishery dependent data as a data process into the MSE, which we currently do not have. You know, it could be as simple as taking parameters from the stock assessment and just using that.
Having observation
But
error.
yeah, and adding observation error, but you know, it could potentially, I think you've caught on to it, it starts opening a can of worms.
I mean, I kind of agree with this, that the fishery is seeing their fishery dependent things going on. I don't think you need to put it into the MSC and start, like what I would do for this is like for each region, and you already have this, just plot the FIS versus the fishery CPE and fit any model to it. And there's the relationship, and define when things that's breaking down. But you've got to loosen up the exceptional circumstances, because there's more things that can happen
Yeah.
in there, just to start, you know, at least making it quantitative, like making it more objective, right? Than having, because sometimes it depends on who's at the annual meeting. You get 3 really outspoken people who want to really emphasize something about their data, but you can't. You always have to go back and look at the data. So.
Yeah.
So it'll be outside the 100% projection interval for a prediction interval for regression.
Yeah, and you don't even have to project or anything, right? You just put the recent data point on the plot.
Yeah.
And see if it's within expected behavior. And then if it is, then you can start to say why, and maybe even then it's part of the annual meeting. You know, vary it, because you're talking, it's going to have to be regional. It can't be coastwide. So now you're back into the regional, maybe it's a negotiation topic to discussion. It doesn't have to go into formal exceptional circumstances.
I like that better than trying to use the MSC to predict fishery dependent observations.
Yeah. Ian and I have been having a lot of discussions around that, and then it just always fills up our board. Okay, so given that background of how you would define declaring an exceptional circumstance, this is then a slide, and these have been presented in the past, of actions to take if an exceptional circumstance is declared. And that could, basically summarizing this involves the SRB and the MSAB and declaring an exceptional circumstance. And then exactly what would be done, a review of those simulations, maybe opening up a reconditioning of the operating model, and then reevaluating management procedures and deciding if a new management procedure is appropriate.
So it's almost like you just went through the exercise, right? We
Yeah.
got one point that falls out, reviewed it, like,
Yeah.
review right now.
Yeah, but
For these reasons.
I think it's good to have these bullet points here to really identify that it does require the review. It requires the SRB to be a part of it. And then, potential outcomes are the reconditioning of the operating model and reevaluation of the management procedures.
We're not talking about doing a stock assessment right away.
Yes, and that's because we're currently on the annual process. And what you'll see is we're currently investigating whether to move to a biennial or triennial stock assessment process. So we have that in there just in case that comes into play. So yeah, if this was a year where we were not going to conduct a stock assessment at all, we're going to apply empirical rule, then we would have that discussion.
Yeah.
Should we do a stock assessment? Do we have time to do a stock assessment? Might be the first point. And then, how would that then feed into the decision-making process?
So if, I'm wondering about C and D. If the exceptional circumstances as they're defined are all seemingly scientific issues, what's the role of MSAB in finding the exceptional circumstance?
That's a really good point. I think if we brought fishery-dependent data in, that we might want to consult with the MSAB if something seemed out of whack there. They might have some good insights. But as it stands now, yeah, the MSAB likes to be involved, and informed. In the annual process, though, we don't always have a fall MSAB meeting, so it may be difficult to actually bring them to the picture. But yeah.
Yeah, it's funny because recently, just last week, we're having a meeting. It was an MSE meeting. I was trying to clearly separate what the role of the management working group is and science working group.
Mm-hmm.
And trying to get an MSE done quickly. In the management working group, someone who was questioning like whether we can get an MSE done quickly enough started bringing up the issue of what recruitment scenarios are we going to look at. I said, well, we talked about that in the last 2 days in the science meeting. What do you want to do? Like, what do you care? It should be.
Do you want to have your hands in that? The answer is it's going to take a while.
Yeah, exactly. That's not how you get it done quickly. You just start blowing things up.
Mm-hmm.
You don't want to minimize people's concerns and stuff, but I think it's kind of good to separate them.
Yeah.
For that reason. And just let the management group focus on their role.
Yeah. And we've recently updated the terms of reference, I guess, about a year ago for the MSAB, and we've really tried to identify their role a little clearly.
Well, I was going to say, and it's just like us not commenting on that deviation between Region 2 and Region 3 on what to do about it.
Mm-hmm.
We could say, well, then adjust the TAC a little bit.
Yeah.
But no, we're saying it's not an issue right now. Go ahead and do what you want to do.
So speaking of timelines and this exceptional circumstance actions should be thorough, but they shouldn't take so long that the system becomes unresponsive. How long do you think it would take to go through those 4 steps?
Well, if we back up to, there's an assessment. Well, in October, we get survey results. So let's think ahead. So this October, we'll get survey results. Adjust those projection plots once I have survey results and be able to see that in October. I guess the longest time span is the SRB would not meet again until June after that next observation point. So if this SRB is concerned, well, we got one year out of, in Region 3 is in the proportion of the biomass. Let's see what happens next year. You will not see that until next June. So that would be after the decision-making process for that year's TACs or TCYs already occurred. So it would be a little bit of a lag in the system of responding to these. And the SRB could review it in June, and then it could start the process right then. of reconditioning the operating model, but it would probably take till next June to really get results back, unless it was,
Talking about a 2-year process.
it could be, yeah,
Between it being exceptional circumstances being declared and some
October
management
to,
response to that.
yeah, it would be probably between 1.5 to 2 years. And it might, the second decision-making meeting, the second annual meeting after the exceptional circumstance was declared is probably when results could be brought. But bringing the SRB into the whole process might be a little challenging with the June, September. It would be a rush process, because conditioning the operating model, doing the simulations, deciding what to simulate, there's a few steps in there.
So 1 to 2 fishing years before.
Yeah.
Change.
Yeah.
That doesn't sound terrible, but it sounds maybe on the sort of the outside end of what would be acceptable in terms of the speed of the mandatory response.
Yeah, I mean,
Given the life history.
yeah. As we do with the stock assessment, as Ian mentioned, if something goes off the rails with stock assessment, he gets the new data after the September SRB meeting, and it's like, whoa, that was unexpected. We could always have that follow-up call with the SRB. So if we did put that into the process, in November, follow-up call with the SRB, if something identified in September continued with
Yeah,
the
I
new
got you.
observation, then that would actually bring it down to 1 year.
That might be worth trying to formalize.
Okay.
Because
By exceptional circumstance as well. It might differ.
Mhm.
The first, second one.
I mean, I think having a high threshold for triggering exceptional circumstances is okay if the response can be relatively rapid when it occurs.
Yeah. Yeah.
And I do like having a high threshold. I don't think we want to be triggering this thing that often, but then we have to sort of think ahead about what the response would be so that it can happen fast.
Good point.
I also wonder about, so I guess if you go back slide, so looking at the original acceptance. Yeah. So even C here, if you're redoing your assessment at a reasonable interval, would you ever need to drop everything and deal with this? So, because this assumes you don't really know what the impact of changes are unless you've done a simulation. So for example, I can see, let's say you're doing every 5 years, you recondition your operating model, and now you're collecting all this new information. You find out some things are changing. Well, you're putting it in.
Mm-hmm.
So your new projections are going to reflect it. There's really nothing you're going to do in those 5 years that's going to change anything. So I wonder if we even need C, because that's really already embedded in the process.
We did it. I think we have an example of that might help with determining how necessary C is, and that's when the stock assessment estimated mortality in the third and 3 of the 4 models instead of 2 of the 4 ensemble models. And it did change the paradigm, a bit on the advice for the TCUI. And so there was a lot of concern in the commission and the conference board and the stakeholders that, oh, wow, this is really something new. It's resulted in a higher TCUI than we expected being recommended from the stock assessment. And the first question, well, not first, but maybe the second or third question they asked was, are the MSE results moot now? Are they even informative? And so I did a lot of work looking back and saying, and that was when we reconditioned the model. So let's recondition the model just to make sure. And then we compared before and with the new reconditioned model with this new M. And we found that the results were not that much different in the MSE because it was robust, right? It already had an uncertainty on natural mortality, even though it was fixed in the stock assessments. And so I think that was a good lesson for everybody. And what I've been telling you, you can still trust the results that we did 4 or 5 years ago from the MSE. It has these uncertainties in it. But
good to keep going back to that, even though you may
Yeah.
not be using it, but always, I mean, we've done that. It's like
Yeah.
going back and looking, okay, the MSC we did in 2008 still is fine.
yeah, yeah,
How much impact was made by the short, by the initial work?
yeah,
And so anyway, because even if something I just did have, so you've got a 5-year interval, let's say, of your operating model updates, you're doing a stock assessment every third year in that time frame. Do a stock assessment. Ooh, it said something's different. Now we have to recondition the operating model. You're going to hit the operating model thing anyway.
yeah, yeah, yeah. And I think C comes in to be a devil's advocate a little bit. Here's what Ian was talking about, and sort of the confidence in that when they see a big change in the stock assessment, which may not be a big change in the MSE simulations because it's within that uncertainty, many people still see that as a change, and that change, then we have to convince them that the simulations from the MSE are still valid. So, having this in there might never be triggered, but maybe it's a security blanket.
Absolutely. And it sounds like we need some of them to get people to believe to adopting that procedure. So I want the security.
Yeah.
We're going to disagree on that, but
Okay.
I think there's a lot of important things for people to focus on.
Yeah.
You need to put more energy into those few really important things, less energy into things that they think are important, but really are not.
Then you have to put energy into convincing.
Well, then that's what you can focus your energy on, is convincing them, continually bringing this information forward, saying, look, logically, if you've got a 5-year interval between your operating models, probability wise, it's a real high chance. It doesn't matter.
Yeah.
Right. It's
Yeah.
going to get dealt with in the next operating model update.
And we've actually been discussing the 3-year time frame. If, we're doing the stock assessment, a full stock assessment every third year, that conditioning the operating model every third year after that full updated stock assessment might be good. So that's even shorter.
And even then, right, take your oldest operating model, run those projections and leave them. And every time you update it, go back and say, okay, how was our,
Yeah.
and people might get confident saying, yeah, okay, this thing really is a big slow moving tanker. It's not, it bounces around.
Yeah, that's a good idea.
So they go.
So that is what I have on exceptional circumstances. This presentation is divided up into some segmented concepts. So if it's okay, I'll move on to the next concept, objectives. As I mentioned this morning, there are currently 4 primary coastwide objectives that the Commission's working with. And these are 4 objectives that the Commission really wants to focus on, but there are multiple objectives that you can see in the appendix of the SRB document. But these, 4 are pretty generic objectives. The conservation one, be 20%, maintaining above the B36% is B, and then optimizing TCY and minimizing variability. Let's see if it's the next slide here. Well,
Yeah, why do they continue to use optimize?
instead of,
Maximize or minimize.
yeah,
Or-
optimize comes in to incorporate that we might not necessarily be just maximizing the TCY because there are other constraints or there's other concerns that aren't captured in these objectives. So I think that they're trying to use that as we're not necessarily trying to maximize. And where this really started coming from is them realizing that with variability, the 4th objective here, they may be opting for a TCY that is not maximized in order to reduce that inter-end variability.
So switch C and D,
We used to have that.
if you switch C and D, and then D was maximized average TCY subject to A through C.
And we
that
used to,
deals with that.
we used to do that. The commission wanted to reverse them back to this way. And now it's now optimized.
Well, as far as fishery objectives goes, that doesn't work. It's not quantitative. It's not measurable.
yeah.
You can't get performance things to it and so on.
I know how to maximize or minimize. Subject to constraints. I don't know how to optimize.
Yeah.
So
So,
optimize, then it needs more wording. Right?
Mhm.
Optimize subject to these weights on these performance metrics.
Mhm.
That would be an optimization.
yeah, so I see your point, and actually these two objectives were put in there for them to actually evaluate simultaneously the CND in a way that they could then look across management procedures and decide which one is best. But again, that's subjective. It doesn't have a clear performance metric associated with it.
And maybe that's okay because these are their objectives. They can define their objectives however that gets them to adopting a management procedure.
Then success, right?
Exactly.
You could also lead to an endless debate
Mhm.
because nobody knows what optimize means.
Yeah.
Each person's got a different definition.
Yeah.
Is that right? I mean, do they seem to have different definitions of it? They seem to be roughly on the same page.
On the coastwide level, maybe they're pretty similar when it gets to regulatory area level.
It's not what will happen. Yeah. It'll get the regionalization will get pulled into it.
Okay, so yeah, that's something that we're having an MSAT meeting in the fall. Maybe that'll be something good to bring up with the MSAT again before we talk to the commissioners. So there are these objectives, and I want to just take a look at what happened last year at the annual meeting. And in the top box there, and associated with the top figure stock status, we see that from the stock assessment, we have a stock status that's increasing above this 36% threshold target, whatever you want to call it. And things look really good. And we also note that the long-term average stock status when fishing at SPR 43% would be about 38%. So we'd be above that target 36% as well with the current interim management procedure. Conversely, when we look at current data, the catch rates are at their lowest level seen since the early 1990s, and that's catch rate plot on the bottom there. And you see they declined by 10% just last year. And so they're really low, and people aren't happy about that, obviously. The FIS WPUE is also at its lowest value since the early 1990s. And so recent commission decisions have been accounting for this concern. And they've actually reduced the TCUI from the 43% SPR, and they've been adopting 52%. So, yeah, I think last year they adopted a TCUI associated with a 52% SPR. So they've been taking a precautionary approach. And so the question is, okay, why isn't the MSE, why isn't the management procedure, this 43%, being used? Why are they deviating from that? And so some of the notes that the commission put in the annual meeting report was spawning biomass is at a 35-year-old, the estimated spawning biomass, 35-year low. Fishing SPR 43%, a high likelihood of stock decline. There's a lot of uncertainty. The adopted mortality limits for 2024 correspond to a 41% chance of stock decline. So looking ahead, what's this chance of stock decline? And concern about continued stock decline. Even though the MSE simulations do show that would be expected at a SPR 43%. So the question here, oops, sorry, did it go back? Yeah. Okay, so what we've been asking here, the secretary, is, are we missing an objective? And so the SRB at the last meeting also made a recommendation to reevaluate this objective B. And it's partly because what we're talking about this morning, that there's been these ad hoc adjustments from the current interim management procedure. So we've been thinking about, okay, catch rates and absolute biomass seem to be important. The catch rates and the current estimated spawning biomass seem to be more important when they're low. There's been statements when the biomass is high, we want to take our catch and reap the benefits. In other words, the threshold objective does not really seem to be that important, as even noted by the SRB. And this isn't the first time this has come up. In 1937, there's a quote from Thompson saying obtaining a catch from a larger accumulated stock would result in less effort, but also less time at sea. So there's an efficiency component about this that has been seen for 100 years, been noted for 100 years now.
Bioeconomics would tell you that.
Yeah, yeah. And Clark and Hare, actually in 2006, when they were developing and doing a lot of their harvest policy work, they noted that a commission's objective is to maintain a healthy level of spawning biomass. And they actually they had an objective to maintain the spawning biomass above a level that was estimated in the 1970s from some of their models. So we've been thinking about, objective related to absolute biomass or catch rate, noting that one, spawning biomass is highly correlated with commercial fishery catch rates, with 90-something% correlation between the two. So, having an objective on maintaining some spawning biomass might improve catch rates as well, would likely improve catch rates. When you use this dynamic relative spawning biomass approach that we're using, it can result in a high stock status, but with a low spawning biomass. The minimum absolute spawning biomass might ensure successful reproduction, although we don't currently have any evidence of that. And then catch rates and spawning biomass, real numbers often have a very specific meaning to stakeholders. They can develop objectives around those, especially catch rates a lot easier. So we're thinking about possibly replacing that objective B, the 36%, with something related to absolute spawning biomass or some measure that results in hardships to the fishery. And one thought we've had is the spawning biomass estimated in 2023. Obviously it doesn't seem like they want to be at that point. They want to rebuild higher than that point. So that might be an objective, a starting point for developing this objective. So the commission actually supports working with the SRB and the MSAB on this new objective. We're going to have an ad hoc MSAB meeting this summer to discuss this objective as well. A lot of MSAB members are been putting a lot of thought into it as well.
What the logic was behind the absolute versus relative biomass? Like, why not just adopt a higher SPR table?
In terms of related to,
Why not be 48% or?
Yeah, so the current,
because you guys have gone through all this trouble to develop SPR,
yeah,
and teach them all this stuff, and
that's definitely something we'll present to them. Is, look, you can meet your objectives, but we need this objective, because currently with those 4 objectives, SPR 43% meets those objectives, and this is, there's objective A, it meets. Keeps it above 36%, it's about 38% long-term average. And then with yield and variability, the MSAB and the commission has looked at that a lot, and we've looked at curves. It's like the variability starts to increase greatest around 42, 43%. That's when it really starts to ramp up, because the control rule gets hit maybe a little bit more after that. And it seems to be that trade-off between yield and variability. So that's why 43% was chosen. So right now, given those 4 objectives, we have no reason to move away from 43%. even though there seems to be this concern.
But there's an additional objective.
So that's the thing. If we, and so I presented to the commission at the annual meeting. I said, well, what are the probabilities of staying above the 2023 estimated spawning biomass? So we can calculate those with the MSE. We presented those. It was like 1 in 4 chance being below where we currently are with an SPR 43%, and moving up to an SPR of 52%. I think it was like a 30 to 40% chance rather than a 20 to 25% chance. So we could see that trade-off.
Sorry. Why does the probability go up?
So, I mean, yeah, it was the opposite. It was a 1 in 4 chance of being below 2023, and it went to a 1 in 5 or less chance of when you went up to a higher SPR, lower fishing intensity. So we're showing them that chance. And we tried that route of saying, how comfortable are you being below where we are now? These are what the MSC simulation results show. But the objective wasn't fully developed, so it didn't work.
Another thing sorry.
I was just gonna say, I like this. I mean, it's an iterative process stating
Yeah.
your objectives, right?
Yeah.
You sometimes don't know until you see a situation where you're like, well, I don't
Yeah.
like that.
Yeah.
Even though it seems to meet our objectives that we previously stated. And so, yeah, that makes sense to iterate and add objectives when you
Yeah.
realize that you're in a situation that nobody wants to be in.
Yeah.
Part of the difficulty is that when you focus on the median, there's a 50% chance of being below it.
Yep.
So there's
Mhm.
tons of slop room.
Yep.
So even if you just, your second objective, instead of having it 50%, if you use the lower percentile of that distribution, now you're adding some security. So if they really don't like more than a 1 in 5 chance of being below B43, you can keep B43 because, and you certainly don't want to tie this in with your control rule. Keep your control rule so that the ramp doesn't happen until you're in the area where you need it.
Okay.
So this is totally independent of the ramp.
Mhm.
Post control rule is whatever you make it. You're going to have to adjust the height anyway.
Yeah.
To achieve this.
Yeah.
And just focus on the difficulty with that is people's interpretation, understanding of percentiles might be
Mhm.
difficult.
And
But
yeah, we have tried to present that in the past, but from a different angle and showing them like with an SPR 43%, you can have TCUIs down to 23 million pounds. There's, the lower percentile, we're showing them the range of TCUIs, but they're like, oh, but we can have TCUIs of 110 million pounds. It's like, but you can have them down to 23 to 25, and that can happen for a series of years. And now we're learning that, right? And that's part of that iterative process as well.
And the MSC results are only going to be informative if you will actually take that hit.
Yeah.
Go down to 23.
Exactly.
If you censor the low end,
Yeah.
the MSC results are no longer valid.
Yeah.
And if you use something like, let's say, maintain the 25th percentile, it's going to be much more sensitive. Because medians doesn't respond as much as those lower percentiles.
Yeah.
It's going to respond to things like the FIS. Like the FIS uncertainty is now going to affect that much more than it will. So everything starts to make sense. It's like, oh yeah, if we let the FIS blow up, the CV and that blow up, that 25th percentile is going to drop. And it's going to show up in your performance statistics quite a bit more.
Yeah.
Because now, I hate looking at median outputs because it's like, well, nothing matters.
Yeah.
When things do matter, like the probabilities, the risk levels do matter.
Mm-hmm. Mm-hmm. Sean, go ahead. If I may follow up with Sean real quick, is you mentioned about the control rule. One thought of bringing in an absolute biomass objective is to bring it into its own control rule. I know this adds complication to the MP, but potentially having 2 ramps. One ramp is to just avoid when stock status is getting low. The second ramp would be if the biomass is below, say, the biomass from 2023, some absolute level that you start backing off fishing intensity to bring it back up. Instead of, so, you know, you have your control rule with the height and you're saying we can adjust the height and we can reduce this probability. Well, if we have two control rules interacting with each other, then potentially we can act precautionary when we need to, like the commission seems to be doing in the last couple of years. But when biomass is high, we take the full opportunities that are available with an SPR 43%.
Biomass control will require.
Yeah.
You could try it, but it's gonna be-
Yeah, because
things that happen on the ramp don't really.
except the variability.
It causes those immediate reactions when you need it. So
Yeah.
why double complicate it and just move it where it has an effect?
Mm,
You almost have to. It's hard to even see in the projections what the point at which you start going down has. If you want to see what it, then you have to actually go in and find the simulations where it was invoked and then what happened.
I was going to talk about that first bullet point there, spawning biomass highly correlated with commercial fishery catch rates. And the conclusion from that observation seems to be to just use spawning biomass. But because the communication is so important here, maybe the conclusion's the other way around. So just use a simple regression to predict commercial fishery catch rates and have the control rule the objective be based on fishery catch rates.
yeah, and I went down that road for quite a while, and then I had a discussion with some stakeholders, and many stakeholders were like, "Yeah, that makes sense to me," and a few actually pointed out, it's like, yeah, but catch rates are so dependent on so many other factors. And actually, a lot of stakeholders are saying this, that catch rates, one, we can change the catch rates without a change in the biomass. So they're concerned in that, like the switch from J hooks to circle hooks, double, catch rates overnight practically. And then I said, well, what does that matter? You're still efficient in the fishery. That shouldn't matter. That's the key here, right? You have your efficiency and your economics. And they're like, well, actually now, we're so limited by constraining species and other constraints, where we can and can't fish and when we can't fish, that catch rates are totally dependent on that. So I think their concern is that relationship may break down a little bit. So yeah, we've been having that exact discussion though. All right, so let's see, do I have more on objective? No, so that's the end of sort of this coast-wide objective and rethinking this objective. In terms of, we're going to have a discussion with the MSAB. I think any insight from the SRB would be very helpful in guiding the MSAB and the commission on the directions to go. I think we'll all be looking to the SRB and any guidance on this. So still related to objectives and yeah. So I was thinking maybe I just finish this one up and then we can discuss whether we break for lunch or not.
I have to be in the Zoom meeting.
Okay. We can break right now then, because I think that'll be.
I don't think you can talk that fast.
Well, I can go through slides fast, but.
Well, that's fine. I mean, that was a lot.
Yeah, no, thanks a lot.
Hours.
And what time do we want to come back? Perfect.
Lunch here?
Yes, I think it's on it right. All right, thanks. We'll be back at 1:30.
Somebody needs that.